Hello everybody. Hello. Good afternoon. Hello. Am I audible, visible? Please let me know, guys. Yes, guys. Hello everybody. Good afternoon. Yes. NTA Hapta. Very good. Okay, so இன்னைக்கு வந்து what we are going to do da? What we are going to do, please let me know quickly. இன்னைக்கு வந்து what special? Guys, don't forget to like the session because எப்பவுமே I can see lots of selfish people are there. Yes, Jia. Yes, Hajir. Yes, Manchu. Yes, Glado Mastori. I forgot your name. You have mentioned your name, right? I forgot. Yes, complete 12th concept தான் இன்னைக்கு வந்து நம்ம வந்து கவர் பண்ண போறோம். Yes, Hamsini. Yes. நம்ம லாஸ்ட் கிளாஸ்ல வின்னர்ஸ் எங்க இருக்கு? ஹாய் ஜெஹி, தயா. Yes, Varsha. Yes, Ankita, Angeline, right? Yes, Srimukhi. Hi. So, first of all, let me just tell you one more thing. Oh my God, looks like some ghost. Correct. Okay, so right now நீங்க வந்து பார்த்தேன்னா நம்ம what is a description boxல first link எனக்கே தெரியும் மேம் ஏன் நீங்க வந்து எப்பவுமே everyday you are saying the same thing and I mean why we should listen this ஏன்னா வந்து maybe one student might be not aware about நம்ம free Re-NEET crash course da so அதனால தான் I'm introducing. Just give me 1 minute. Okay, those who have not joined நம்ம free Re-NEET crash course, okay, நீங்க வந்து பார்த்தாலே தெரியும் this is happening. Okay, இது வந்து 4999 ஓட கோர்ஸ் தான். அது வந்து we are giving it for 0 rupees. Okay, 0 rupees na நம்ம Re-NEET க்கு prepare ஆன ஸ்டூடண்ட்ஸ் க்கு they need more resources, they need a lot of things. So அதுக்காக தான் actually வந்து we have introduced this. Okay, 0 rupees da 0 rupees. Okay, இதுல வந்து you will be hardly take 1 or 2 minutes. So you can just go for buy now. Okay, in the buy now if you are going for na you will be get this access to this free Re-NEET crash course. இப்போ நீங்க வந்து பார்த்தேன்னா you can see here நம்ம physics, chemistry, biology ஓட what is the classes you can see. Okay, நம்ம live classes வந்து நம்ம appல இருக்கும். So what is the advantage? இப்போ நீங்க வந்து if you are watching the lecture in the app na definitely instantly you can ask your doubts. Okay, so இப்போ வந்து again you have another option here 24/7. Okay, 24/7 doubt solving க்காக நம்ம Ved AI is here. Okay, so இப்போ வந்து if you are asking me ma'am why we should go for this Ved AI, we have Google AI and we have lots of ChatGPT, everything is there, no ma'am, so why should we go for this one? So நம்ம Ved AI is actually created on the basis of NCERT. நீங்க வந்து ஏதாச்சும் ஒரு doubt if you are asking in Google or something, what is the major issue da, what is the major issue, so Google will collect the answers from each of the sites and you will be getting a kind of answer. Okay, ஆனா வந்து if you want an answer specific to NCERT na you can trust நம்ம Ved AI வந்து you can just completely you can just trust. Okay, so that was the major advantage. Okay, so in the madri you can see the test also, so every week they will be updating the test as well. So you can see here and the performance category you can see the performance of your, I mean whatever you have done adoda performance analysis kuda you can just see. Okay, so this is what about our Re-NEET free crash course, 0 rupees da, and I mean nama session in between the session also you can ask your doubt. Okay ba? Yes, Praveena is Divya, right? If I'm not wrong. Tell me. Okay, so idellame vandu mudinjiruchu. Let me just close everything. So what we are actually looking for today. Okay, so tell me da இன்னைக்கு என்ன தான் பண்ண போறோம்? One second guys. Ready ada everybody? Ready na? Give me a fire quickly. Give me a fire quickly if you are ready for the session. If you are ready for the class, complete class 12th order physics வந்து study பண்றதுக்கு. If you guys are ready, give me a fire quickly. I'm not Divya. Then I forgot your name. Not Pravina, right? Yes. Yes, everybody is ready. Everybody is ready. Okay, so now we are going for the first chapter. Okay, yes, Auntie Joe. Yes. Ochal, why I'm just forgetting all those things. Yeah. Okay, let me see. I will note it down here. So yes. We are going for number first chapter. First chapter or name and it is nothing but ma'am, nama electric charges and fields. Adala first I'm going to ask about electric charge. Tell me now, what are the things you know about electric charge? Electric charge is a scalar or a vector quantity. First of all, you should tell me that. Okay, is it a vector or a scalar quantity? Tell me that first. It is actually a scalar quantity. Okay, and what is the unit? Can you please let me know what is the unit of this charge? It is nothing but ma'am, very simple. Idu the coulomb da. Okay, charge na coulomb da adoda unit varudhu. And idukku we know that if I'm giving you two positive charges, what comes in your first mind illa ennada first varaporum? Two light charges, definitely they will repel. Okay, ஒரே character the students na definitely what will happen அவங்களுக்குள்ள கொஞ்சம் separation இருக்கும். கரெக்ட்டா? So அந்த repulsion இருக்கும். இப்போ if I'm asking you about the, okay, if I'm asking you about what is it? I have talked about this the light charges. இப்போ unlike charges இது positive, இது negative. அப்படினா என்ன இருக்கும்? Attraction. Okay, so light charges will repel, unlike charges will definitely attract. And also we have studied about the major properties. What are the major three properties? 3 or 4. Okay, let us go for 4. Okay, so what are the four important factors or let's say properties which we have studied about the electric charge? First on the ma'am, it is very important. Okay, charge or additivity. What is charge or additivity? If let us say I have Q1 charge, Q2 charge, Q3 charge. So tell me now, what is Q total? Okay, what is the number total charge or amount in there? Very simple ma'am, Q1 plus Q2 plus Q3. Okay, இப்போ என்கிட்ட இருக்கிற சார்ஜ் Q1 இருக்கு, Q2 இருக்கு, minus Q3 இருக்கு. அப்படினா tell me now, what is the total charge? What is the total charge? Tell me everybody. What is the total charge? It will be nothing but Q1 plus Q2 plus minus Q3. ஏனா இது scalar quantity da. So we have to consider the negative sign. புரிஞ்சுதா everybody? Give me a white heart if you understood the first property of charge. Everybody give me a white heart quickly. Yes, very good Manju, very good. Okay, so right now again I'm going for the second property. What is second property? Conservation of charge. Okay, conservation of charge. அந்த டேர்ம்ல இருக்கு மேம், அதோட மீனிங் இந்த கன்சர்வேஷன் எல்லாமே அந்த டேர்ம்ல இருக்கு மேம். Conservation of charge, which is nothing but நம்ம total charge of an isolated system. Okay, அது எப்பவுமே கான்ஸ்டன்டா இருக்கும். Okay, total charge. Okay, thank you Mahant, right? Yes. Okay, the total charge of the system will be always, Grishma, it's long time. Okay, long time no see. Where were you? Okay, so nama charge conserved. The total charge will be always constant for an isolated system. And it is important numericals expect panna mudiyumla andha madri irukra oru property da nama third property. Adu nothing but quantization of charge. What is quantization of charge? Nama total charge will be always the multiple of E. Multiple of E. Can you please let me know the value of E? Can you please let me know the value of E, everybody? Can you please let me know the value of E? E it is nothing but 1.6 into 10 to the power minus 19. Okay, very good Angeline, very good. Okay, so it will be always the integral multiple of E which will be 1.6 into 10 to the power minus 19. Very good Samiksha, very good. Okay, so this is what the important thing. And also I can say that this charge is invariant. Why I am saying it is invariant? ஏன்னா இப்போ இந்த charge if it is moving with a velocity v in different frame of reference, will the charge value will change? Never ever. Even if it is even if it is going with a velocity v in this frame or in this frame, don't even care about it. This will be always same. This is why we are saying in the charge invariant da. Purinjada everybody? Now I'm going to ask you a question. if I'm saying, okay, in the body, okay, this body is positively charged body da, then tell me what you will understand. If I'm talking about this body, okay, in the body vandu positively charged da, appadina what you will understand? Could you please let me know what you will be get to know about this positively charged body na, what you will understand from it? Can you please let me know? Can you please let me know? Okay, Grishma, okay. இது வந்து nothing but இந்த ஒரு bodyக்குள்ள less number of electrons தான். Okay, electrons na என்ன? Negativity. So less number of electrons தான். Okay, so then I will say, okay, இப்போ இந்த positive charge விட electrons ஓட charge இல்ல negative charge கம்மினா அதுக்கு வந்து more positive charge இல்ல. So I will say this is a positively charged body. Okay, and இப்போ வந்து if I'm saying about a negatively charged body, what is the meaning? Negatively charged body, more number of electrons will be there. Negatively charged na, it is nothing but more number of electrons. Okay, more number of electrons will be there. Now my question is, if I'm having two identical bodies, okay, careful answer panikoda. If I'm having two identical bodies, so one is A, another one is B. So idu vandu positively charged da, idu vandu negatively charged da. So right now tell me which one is having the more mass. Okay, which one will have more mass? Can you please let me know? Okay, இப்போ வந்து two identical bodies இருக்கு, A and B. A na positive charge da, B na negative charge da. அப்படினா tell me which one will be having more mass? Yes. Very good, Angeline. Very good, G. Very good. Not very good. Okay, so mass will be more for B. Why? Can you please let me know the reason? Can you please let me know? Mass will be more in B, which means that one negative charge illa. Negative charge na more number of electrons, correct? More number of electrons. So more number of electrons சொல்லும்போது, okay, more number of electrons சொல்லும்போது and the extra electrons oda mass கூட it will be added, right? அப்படினா always நம்ம negatively charged body க்கு தான் actually வந்து more mass will be there. Now let us, I'm just keeping another body C, identical da. இது வந்து neutral. Can you give me a relation connecting mass? Okay, so can you give me the increasing or decreasing order of mass? Everybody quick up. Everybody quickly you can give me the answer. So how will be the relation? Mass will be more for B. அதுக்கப்புறம் it will be C, neutral body. இந்த neutral body விட கம்மி தான் mass வந்து நம்ம positively charged body. So if you understood, can you give me a green heart? Usually I won't ask for green heart, right? If there is a green heart, give me green. Yes, very good, Manju. Yes, Varsha. Yes, Ojal. Very good. Yes, Murali. Yes, Jia. Yes. So this is what the relation. Okay, wow? Understood? Very good. Wow. Super green hearts. Yes. So this is what we need to study in the first part. Okay. Now, another thing. We are going for Coulomb force, or let's say electrostatic force. Can you please let me know? Simple as what is this Coulomb's law? Coulomb's law nama very simple. இப்போ வந்து 2 point charges இருக்குல்ல, இப்போ வந்து எனக்கு Q1 இருக்கு, எனக்கு வந்து Q2 இருக்கு. Okay, இந்த 2 charges ஓட center to center distance தான் actually வந்து நம்ம R. அப்படினா guys, smash the like button. Yes, Manju, why these people are like this da? Okay, we hate such kind of students, correct? Okay, so now Q1 and Q2 separated by a distance R. அப்படினா அதோட force ஓட value என்னடா? The Coulombic force will be K into Q1 Q2 divided by R square. இது வந்து central force தான். Okay வா? இது வந்து central force தான். Central force னா என்ன? எப்பவுமே இந்த force will be acting center to center. Okay, எப்பவுமே இது வந்து center to center ஆ இருக்கும். And another one thing if I'm asking about, the Newton's law is valid or here? Okay, valid or not? இப்போ வந்து நம்ம third law இல்லடா action reaction. அப்படினா அது வந்து இங்க வேலிடா இல்லையா? Definitely valid, ma'am. இப்போ வந்து இந்த Q1 இல்ல ma'am, இந்த Q1 will exert a force on Q2. Okay, அந்த மாதிரி இந்த Q2 will also exert a force on Q1, and the two forces will be equal and opposite. Okay va? Let me repeat again. இப்போ வந்து எனக்கு இருக்கிறது ஒரு Q1 தான். இங்க வந்து Q2 இருக்கு. So let us say இது வந்து light charges. Okay, both are positive. அப்படினா what will happen? They will experience a repulsion, right? So actually வந்து சொல்லும்போது இந்த Q2 will exert a repulsive force and in the Q1 will exert a repulsive force. So in the two forces வந்து equal and opposite da. So I could say that in the force வந்து எப்பவுமே what is a Newton's third law வந்து it will obey, and also this is depending upon the medium. Okay, நம்ம gravitational force விட the major change which is in the Coulomb's law இல்ல electrostatic force வந்து it is actually depending a medium. So tell me da, இப்போ வந்து I'm introducing, okay, இந்த two charges இருக்கிறது வந்து if it is an air நம்ம இந்த equation வந்து valid தான். Okay va? Now the same system in the two equal charges separated by the same distance, I am keeping in a different medium with the dielectric constant K. Okay, I'm introducing with dielectric constant K. Appadina what is going to be the new force in terms of the force in air or let's say in vacuum? Can you give me the answer quickly? So what I was asking, இப்போ வந்து two charges separated by a distance are அது வந்து airல தான் இருக்கு. அப்படினா எனக்கு கிடைக்கிற force வந்து F. Okay, இப்போ வந்து same system. I'm not changing the magnitudes, I'm not changing the distance of separation, I'm just replacing over here. Appadina what is going to be our new force? Okay, what is going to be the new force? Can you please let me know? Idu vandu if dielectric constant is K, then I can say that F by K. Our force will reduce by 1 by K times. Understood? Now give me a red heart quickly, everybody. Give me a red heart. Come on guys, where is your energy? Let's smash the like button. Okay, it is becoming in the attendance button. So let us say. Okay, everybody. Perfect. So இதுதா வந்து மேஜரா we should study in the case of நம்ம Coulomb's law. Okay, Coulomb's law ல இதுதா வந்து மேஜரா இருக்கிறது. And நம்ம 1 by 4 pi epsilon naught ஓட value வந்து 9 into 10 to the power 9 தான். And tell me what is epsilon naught? What is epsilon naught oda value? 8.85 into 10 to the power minus 12. In the what is in the values ellame vandu note pannikoda. Maybe nama question paper la in the answers ellame irukum, but we cannot guarantee it. Okay, so please study all these values, which is very important. Okay bala, deal everybody. Now it is the time for electric field. Okay, electric field சொல்லும்போது, okay, when I'm talking about electric field na இப்போ வந்து எனக்கு ஒரு சார்ஜ் இருக்கு. இதுதான் வந்து என் சோர்ஸ் சார்ஜ். What is capital Q? Capital Q na source charge. Okay, capital Q na என்னடா source charge da. Deal. Thank you Ankita. Yes Ojal, very good. Okay, so I can see the right answers also. Soumya, then Varsha, Manju, very good guys, very good. So இப்போ வந்து நம்ம source charge, okay, நம்ம source charge இருக்கு. So இந்த source chargeனால அதோட influence இருக்கும்ல. இந்த ஒரு chargeோட இப்போ வந்து if I'm coming with a perfume, okay, good perfume. So அந்த smell வந்து spread ஆகும்ல. ஆனா வந்து அதுக்கு limits இருக்கு. Correcta? So it won't be experienced. And the smell வந்து we cannot experience in a far distance. So அந்த மாதிரி இந்த source charge Q நால அதோட ஒரு influential area இருக்கும். Okay, அதோட ஒரு influential area இருக்கும். So அந்த area தான் actually வந்து we used to say electric field. Okay, இப்போ வந்து ஏதாச்சும் ஒரு கேஸ்ல, okay, if you wanted to find the electric field na, what is actually you should do? Wherever you wanted to. Okay, இப்போ வந்து எனக்கு field வந்து இந்த பாயிண்ட்ல தான் கிடைக்கணும். Okay, இந்த source charge Q நால what is the field at this point na? First of all, I can introduce a test charge. What is this test charge? Can you please let me know? What is this test charge? Okay. Very good question, Grishma. Very good question. If you are staying till the end, na, definitely I will take. Okay. That is what the thing. Okay, so right now we have to find we have to introduce a test charge. Test charge na enna? It is nothing but a charge which is having positive magnitude சொல்லும்போது 1 unit da. Okay, 1 unit சொல்லும்போது it can be 1 coulomb, Can you please let me know? இப்போ வந்து இந்த test charge-க்கு 1 coulomb value possible ஆ இல்லையா? Yes or no? Possible na tell me yes. Okay, possible illana give me no. Quickly. I wanted to know. Please, please, please. Unit charge that agreed. My question is, it can be a value which is 1 coulomb. Positive da, very good. Hamsini is saying yes. Others, yes sir, yes sir. So it cannot be possible da. Okay, it cannot be possible. Understood everybody? Understood everybody? So what I was saying, ipa vandu even if we are saying idoda magnitude vandu 1 unit nalum, it cannot be 1 coulomb and all. Ena inda 1 coulomb illada adu vandu periya, I mean it is a big charge da. 1 coulomb itself is a big charge da. So definitely it can be a very small value, which means 1 nano coulomb, 1 micro coulomb, 1 pico coulomb. So that is what the range. Okay, I will tell you why. இப்போ வந்து இந்த charge இல்ல. Okay, just listen da, just listen observe, you will get to know. Okay, so simple. Let us go with the perfume. Okay, so I mean you people are sitting. Okay, நம்ம Jia இருக்கு, Joshua இருக்கு, Varsha இருக்கு, Saushinya இருக்கு, Angel இருக்கு, Ojjal இருக்கு. Everybody is sitting in the classroom. Okay, now I am coming with the perfume. Okay, so அந்த perfume ஓட smell வந்து அவ்ளோ intensive ஆ இருக்கு. Okay, it is that intense. Okay, so right now my question is, okay, I am standing here. Okay, now let us say nama Ojjal is standing over there. Okay, Ojjal will be getting the smell of the perfume, correct? Ana vandu just understand, ipo neenga vandu paathena someone else is coming, entering into the class. Okay, entering into the class. Okay, let it be Grishma. Grishma is entering into the class. So when Grishma is entering into the class, Grishma is also used to one good perfume. Okay, so adoda smell kuda it is that intense. So right now I'm asking to Ojjal, okay, can you just experience the individual smells? Okay, in the perfume, one is let us say lavender, another one is let us say jasmine. So can you experience the exact smell? No. Okay, so adikaga what should be the condition? The people who are here, no, they should not have any smell, which means and the smell should be very very small, and the charge value, which means in the test charge value vandu it has to be very 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 good, Varsha, very good. It will be a mixture, correct? Ana vandu exact smell kadaikanumna one should have, which means the source charge should be very high comparing with the test charge. Understood ada? Otherwise you will get this, I mean in the two charges oda combination illana adoda combined intensity da namu vandu experience panna porom. So it has to be a very small value. Adanala da electric field ku vandu we will be giving this equation, limit q tends to 0 f by q. Let me just mention it as q naught. Okay, why q naught tends to 0? And the test charge oda value vandu it should be almost, okay, it should be almost close to 0. Okay, இப்போ வந்து அதுக்கு larger magnitude இருந்துச்சுனா definitely the field வந்து whatever is experienced at that point will be having a contribution from source charge as well as number test charge. Understood? That give me a white heart. Everybody should give me a white heart if you understood. Everybody. Okay, so that is what we are saying. Number test charge oda magnitude vandu 1 unit ah irukanum. Then also it has to be very 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 small. Adinala da inda oru term நம்ம NCERT பாத்தேனா இந்த limit q naught tends to 0 அந்த ஒரு value பார்க்கலாம். Okay va? Now another thing, இப்போ வந்து I'm just asking you, okay, I'm just quickly asking you, இப்போ வந்து இது வந்து ஒரு point charge இல்ல, source charge q. அப்படினா tell me what is the force experienced, or let's say what is the intensity experienced at this point, which means nama field due to point charge. What is going to be the value? What is going to be the value? Everybody, guys, don't forget to like the session. Don't forget to like the session. So tell me now what is the electric field due to point charge? Very simple, ma'am. KQ divided by R square. What is then? Tell me what is R? What is R? R is nothing but the distance from our source charge to the point where we need to find the field. Okay, R na enna? Nama charge, nama source charge la irundha. Okay, nama source charge la irundha nama test charge varaikum and the distance illada, that is what nama small r. Guys, smash the like button, guys. Yes, very good, Ajal, very good, very good. Okay, so this is what the first part of number electric field. So ipo vandu nama electric field ku appuram we are straightly going for dipole. Okay, what is dipole? What is dipole? Can you please let me know what is dipole? Dipole na two charges separated by a very small distance. Okay va? Dipole na enna? Two charges. And the two charges vandu edachum oru connection iruka? And the two charges ku edachum connection iruka? Okay, tell me everybody. இல்ல ஜோஷுவா, ஆக்சுவலா வந்து நம்ம இக்குவேஷன் பார்க்கும்போது அதுல இந்த டெஸ்ட் சார்ஜோட வேல்யூவே இல்ல. புரிஞ்சுதா? k q by r square தான். What is q? நம்ம source charge தான். It is not depending upon நம்ம test charge. Got it? Understood, Joshua? So that's why it is not affecting the final result. It will be Newton per coulomb தான். இல்லனா volt per meter தான். Okay, very good Srimuki, very good. Two equal and opposite charges da. Okay, it will be two equal and opposite charges da actually vandu நம்ம dipole la. And now I'm just asking you, okay, I'm just asking you, idu vandu q, this is what minus q, this is actually coming as the distance L. Okay, அப்படினா இதோட strength indicate பண்ற ஒரு quantity தான் நம்ம dipole moment. Can you please let me know the dipole moment ஓட what to say mathematical expression in the dipole oda strength da what we are actually getting from the dipole moment. In the dipole moment oda expression, this is what the given data, two charges equal and opposite, so q da nama charge, in the two charges kulla separation da L. So now tell me in terms of this, please let me know what is dipole moment. Everyone should get a slap. Everyone. What is this? What is 12, guys? Tell me what is 12. What is 12? Tell me. I agree. It is 12. Tell me what is 12 or what is there? Very good, Joshua. Very good. Very good. It should be Q into L. What is that? What is that? Dipole moment na charge into distance of separation da. Okay. So charging in a Q da. Distance of separation. What is distance of separation? L. So what will be the answer? Tell me. What will be the answer? Q into L. Why you are getting confused with 12? I will tell you. So ipo vanda idudha vanda minus q. This is whatever plus q. So they will give a distance from the center. This is what L. Okay. Ipo vanda nama center la irundha inda charge varaikku irukra distance da L na. Now you could say P is equal to Q into what is distance of separation in this case? Can you please let me know what is going to be the distance of separation? Tell me everybody. What is going to be the distance of separation? Idu vandu L da. So this is going to be L. L plus L, it will be 12. Understood why it is coming as 12? Why it is coming as L? So basically, don't study this equation. Just study this equation da. The charge into distance of separation. அப்படினா அந்த equationனால confusion இருக்காது. Okay va? So right now if they are giving from the center na distance of separation, it will be twice. Okay, if they have given from minus q to plus q, idudha vandu distance, அப்படினா direct ah vandu substitute பண்ணலாம். Understood na? Give me a white heart quickly. Everybody. ஆமாடா NCERT formula la confused ah irukku, but whenever we are studying, no, adu vandu you have to study. Okay, what is this L, what is this q, adula vandu clear ah oru clarity irukkum. Illana whatever we are studying, there is no point in that. புரிஞ்சுதா everybody? Everybody understood? Yes, perfect. So அப்படினா நம்ம electric dipole இருக்கு, அதோட dipole moment வந்து we have discussed. அப்படினா tell me இந்த dipole வந்து vector இல்ல scalar? Ma'am, அது கூட தெரியாதா? Very simple question ma'am. அது வந்து vector, VECTOR, vector da. Okay, அப்படினா definitely you have to tell me the direction. How you will be telling the direction? It will be always minus to plus da. What is the direction? Always vandu minus to plus da vandu nama dipole oda, sorry, dipole moment oda direction. Very good Ajal, very good. Kamachi, right? Yes. Manju, Joshua, very good. Soumya, Ankita, yes, very good. Saujanya, yes, this is what the important thing. now இப்போ வந்து என்கிட்ட ஒரு டைபோல் இருக்கு. ஓகே, இது வந்து plus q, இது வந்து minus q. எனக்கு வந்து two different positions இல்லனா ஜெனரலா, ஓகே, ஜெனரலா வந்து எனக்கு வந்து இந்த what to say நம்ம டைபோலோட electric field தெரியணும். அப்படினா I will be teaching you one equation. Study this equation. Electric field at any point due to an electric dipole will be coming as kp by rq into root of 3 cos square theta plus 1. Just study this equation. Just study this equation. Okay. இந்த டைபோல் இருக்கேல்ல, இந்த டைபோல்னால field will be experienced at different points. Okay. இப்போ வந்து ஏதாச்சும் ஒரு பாயிண்ட்ல if you need to get the dipole na, just use this equation kp by r cube into root of 3 cos square plus 1. இப்போ வந்து ஆக்சியல் பொசிஷன்ல வேணும்னா, ஓகே, இதுதான் வந்து நம்ம ஆக்சிஸ், டைபோலோட ஆக்சிஸ். இப்போ வந்து இந்த பாயிண்ட்ல கிடைக்கணும்னா நம்ம தீட்டா வேல்யூ will become 0. ஓகே, நம்ம தீட்டா வேல்யூ will become 0. ஆக்சியல்னா தீட்டா will become 0 degree. Okay va? இப்போ வந்து equatorial na what will be the angle? Can you please let me know? Equatorial na what must be the angle theta? It should be 90 degree. Understood everybody? Understood everybody? So this is how the dipole minus q plus q. இப்போ வந்து this is the point where I need to find the field na, நம்ம center of this dipole la irundhu I will draw a line. This is what r. This is what r. And this is what nama angle theta. This is what our angle theta. அப்படினா axial position la find பண்ணனும்னா what is going to be the angle theta? 0 degree. Equatorial position na what is going to be the angle? 90 degree. So இப்போ வந்து அந்த ஒரு equation இருந்துச்சுனா you can study. Okay, you can solve any of the problem in this. Understood? Now give me a green heart quickly. Everybody. I want everyone's response. Okay, so this is what nama electric field. Now we are going for the another topic which is nothing but ipo vandu nama dipole we are placing in an external electric field. Okay va? So ipdi da nama external field irukke. Okay, ipdi da nama external field irukke. Idukulla I'm going to place, okay, I'm going to place a dipole. Okay va? So inga vandu minus q irukke, inga vandu plus q irukke. Okay vada? So now tell me, I just wanted to know, please let me know. இப்போ வந்து நான் வந்து plus q. Okay, இப்போ வந்து நான் வந்து plus q. இதுதான் வந்து நம்ம field ஓட direction. Okay, நான் வந்து plus q, field வந்து இப்படி தான் it is going. அப்படினா what is going to be the direction of force experienced by plus q? The direction will be towards my left side or towards my right side. Okay, I'll repeat the question again. Okay, again I'll repeat. So இப்போ வந்து பார்த்தேனா நான் தான் வந்து plus q. Okay, field in the direction la da it is going, which means towards my left side la da actually வந்து field is going. அப்படினா நான் வந்து ஒரு plus q charge எனக்கு வந்து force experience பண்றது in the direction la, which means towards my left இல்ல towards my right or to be specific in the direction of field illa opposite to the field. Very good Srivarshini, it will be left side. Okay, so in the charge will experience a force in this direction. Can you please let me know the magnitude? Can you please let me know the magnitude? Charge on the q da, field on the e da. Appadina can I say that the force experienced by plus q is qe and it is towards the left hand side? Understood na? Give me a yellow heart quickly everybody. Appadina my question. Okay, appadina my question. What about this minus q? What is going to be the direction of force experienced by minus q? Will it be towards my right hand side or towards my left hand side? Or more specifically in the direction of field or in the opposite direction of field? What will happen? Minus q alla. So it will be always, the force will be experienced. Very good Soumya. It will be always opposite to the field da. So this will be qe in the opposite direction. So அப்படினா if I am placing, okay, இப்போ வந்து இந்த torque வந்து, so இந்த dipole வந்து if I am placing at a uniform field la da I am just placing. Okay, நான் வந்து actually வந்து uniform field la da இந்த dipole வந்து I have placed. அப்படினா definitely it will be experiencing a net force. What is going to be that net force? Net force. If it is in uniform field na, what must be the net force experienced by the dipole. Very good, Joshua. It will be coming as 0. Okay, so when I'm saying net force is equal to 0, what you will understand? Net force 0. எங்கேயோ கேட்ட மாதிரி இருக்கு. நம்ம 11th ல எல்லாமே வந்து we have studied. Okay, net force 0 னா அதுக்கு வந்து translational motion. There is no translation motion. Okay, when we are saying the net force is equal to 0 na, you should understand there is no translatory motion. Now my question is there any rotatory motion? Sure, ma'am. Okay, one Q is acting in this direction, another Q is acting in this direction. So definitely this will go for a rotation. Okay, there will be a rotation and that rotation is due to the torque, and the torque oda value வந்து P cross E da, which means PE sin theta. நம்ம torque oda value வந்து it is nothing but PE sin theta. புரிஞ்சுதாடா? So அப்படினா I just wanted to know. இப்போ வந்து இந்த dipole இப்படி தான் இருக்கு. I wanted to move it from this place to this place. அப்படினா I have to some work, right? Okay. If I need to replace in the dipole oda position வந்து theta angle rotate பண்ணனும்னா, okay, initially அது வந்து ஒரு angle இருக்கு. Now if I need to rotate na அதுக்கு வந்து கொஞ்சம் work தேவையா இருக்குல. அந்த work oda expression என்னடா? PE cos theta 1 minus cos theta 2. Okay, very good, very good. நம்ம work வந்து PE cos theta 1 minus cos theta 2. அப்படினா of course இந்த work done தான் actually வந்து potential energy store பண்ணிருக்கு. அப்படினா potential energy oda expression என்னடா? It is nothing but minus P dot E, which means minus PE cos theta. Till this understood na, give me a green heart quickly. Everybody give me a green heart. Okay, so torque oda expression vandu we have studied, which is nothing but P cross E, and another one is potential energy, which is nothing but minus P dot E. இப்போ வந்து என் confusion என்னன்னா, okay, இப்போ வந்து என் confusion, guys, don't forget to like this session. Okay, இப்போ வந்து I wanted to know stable, unstable equilibrium. So, எப்பவுமே try to understand when I'm talking about stable. Okay, when I'm talking about stable na, it is actually, it should have a less potential energy. Okay, எப்பவுமே just understand நம்ம human beings la kuda when we will be more stable when we are sleeping, correct? Okay, we are always happy in the universe la irukra ovvoru particle ume illana ovvoru things ume wanted to be in the stable state. Stable state oda speciality enna, adukku vandu less energy da. Okay, எப்பவுமே we wanted to sit like scrolling something like this, or otherwise we need to sleep, correct? So எப்பவுமே இந்த universe la irukra ovvoru quantities ume ovvoru things kume எப்பவுமே it wants to come to the less energy state, which means stable state. Okay, less energy na, less, I mean the least potential energy, which means highly stable. அப்படினா tell me da, இப்போ வந்து I'm just going to give you three angles. Okay, 0 degree, 90 degree and 180 degree. In the three angles la, which one will be at which state it will be stable? Stable na less energy in the U value, nama potential energy oda value vandu it has to be very very small. Appadina what should be the angle? Ma'am, of course it is, yes Varsha, very good. When theta is equal to 0, potential energy vandu minus PE cos 0, which will be coming as minus PE, which is going to be the minimum. So I could say this is what our stable. Okay, when we will be having unstable, for sure 180 degree. ஏனா வந்து நம்ம potential energy minus PE cos 180 na minus 1 da, so this will become plus PE, which means this is the maximum value, which is known as, we can say that this is what representing the unstable state. This is representing the unstable state. அப்படினா what is this 90 degree reference point? ஏனா வந்து potential energy exact ma'am இந்த பாயிண்ட்ல potential energy 2 joules ma'am, இந்த பாயிண்ட்ல 3 joules ma'am, அந்த மாதிரி சொல்ல முடியாது. எப்பவுமே அதுக்கு வந்து ரெஃபரன்ஸ் இருக்கு. Okay va, இந்த ஒரு பாயிண்ட் கம்பேர் பண்ணிட்டா we can always அது வந்து gravitational potential energy இருக்கட்டும், elastic potential energy இருக்கலாம், electrostatic potential energy இருக்கலாம். It is the thing is like there should be a reference point always. நம்ம potential energy சொல்லும்போது there should be always a stable, or let's say there should be always a reference point. அதுதான் வந்து இந்த கேஸ்ல 90 degree. So இந்த 90 degree கம்பேர் பண்ணும்போது when it is going okay 0 degree ல தான் definitely it will be stable. 180 degree வரும்போது it will be coming as unstable. So now my question is when we will be having the maximum torque, at the reference point. ஏனா torqueோட expression என்ன, PE sin theta da. Okay, PE sin theta da. So definitely what will happen da, we will be getting நம்ம torqueோட value வந்து it will be coming as maximum when it comes to at the angle theta is equal to 90 degree. Understood everybody? Give me a red heart if you understood. Everyone should give me red heart. And guys, don't forget to give me the heart as well. Okay, so straight வந்து நம்ம வந்து we are going for the Gauss's law. அதுக்கு முன்னாடி of course we should know na நம்ம electric flux. Can you please let me know the electric flux na என்ன? Electric flux na ma'am அது வந்து field lines da. Okay, அதுக்கு வந்து கொஞ்சம் speciality இருக்கு, அதனால தான் we have given some another name. Okay, so என்னடா அந்த speciality in the field lines? Okay, there will be many field lines, ஆனா வந்து the field lines which is passing okay in the surface வந்து consider பண்ணும்போது if it is going perpendicular to the field. Okay, so இதுதான் வந்து நம்ம surface. அப்படினா the field lines which is perpendicular to the surface, அந்த field lines, அந்த specific ஆன set of field lines தான் நம்ம flux. Okay, flux na field lines da, இது வந்து ஒரு flow da. Electric flux சொல்லும்போது it is nothing but the flow of electric field lines da. And also I should add one more thing, in the field lines should passes through the surface perpendicular to the surface na, I will specifically call it as flux. அப்படினா how we will be finding flux? In the flux வந்து depending upon three factors: field, area, angle between. What is theta? Please let me know how you will be defining theta. I want the exact definition for theta. Okay, இந்த ஒரு கேஸ்ல நம்ம flux ஓட expression வந்து very simple தான். As you guys know, it is nothing but E dot A, or let's say EA cos theta da. Now my question is, what is theta? Correctana definition I wanted. Guys, first target இன்னும் கொஞ்சம் likes தாடா இருக்கு, so you can give me the likes. Okay, thank you Anju. So tell me what is theta. Let it be this like button there. Yes, thank you Grishma. Yes, very good Joshua, very good. The angle between field and the area vector. Don't say field and area, it is actually field and the area vector. So now tell me, இப்போ வந்து இந்த ஒரு area, I mean this is what the area. Okay, அப்படினா how you will understand the direction? Can you please let me know? இது வந்து area na. Okay, this is what the area. Tell me how you will be finding the direction of area vector. It will be always, note பண்ணிக்கோடா, always perpendicular to the surface. Okay, perpendicular to the surface. Very good Joshua, very good. அப்படினா எனக்கு இருக்குறது ஒரு xy planeல இருக்கிற ஒரு what is it plane தான். ஓகேவா, என் surface வந்து xy planeல தான் இருக்கு. Can you please let me know the vector ஓட direction, area vector ஓட direction? இப்போ வந்து xy planeல தான் இந்த surface இருக்கு. அப்படினா what will be the direction of that area? What is the area vector? Give me the direction. XY plane la da irukke. Yes, again very good Joshua. It will be Z direction la da irukum. Yena vandu again perpendicular ah irukanumla. So definitely it will be Z. Very good Srivarshini, very good Hamzini. Yes Jehi, Soumya, very good. So this is what the thing. This is how we will be, I mean this is what we need to understand about the flux. Now in the flux mudichirukke, அப்படினா what you should know after this, flux வந்து clear-ஆ புரிஞ்சிருக்கு. Next is of course Gauss's law. What is Gauss's law? நம்ம flux இல்லடா, நம்ம flux னா என்ன? It is nothing but closed integral E dot dA should be equal to 1 by epsilon naught times the charge enclosed. Okay, what is Gauss's law? The flux through a closed surface. Okay, always you have to mention. And the closed surface na Gaussian surface. What is Gaussian surface? Can you please give me the highlights of Gaussian surface? Gaussian surface na ma'am, அது வந்து எப்பவுமே closed ஆக்கணும். அதனால வந்து நம்ம Gauss's law mention பண்ணிருக்கேன். Closed integral. அப்படினா the Gaussian surface closed ஆக்கணும். And also அது வந்து 3-dimensional ஆக்கணும். Okay, it has to be 3-dimensional. அப்படினா closed surface 3-dimension, and also in the Gaussian surface order shape, size எல்லாமே வந்து doesn't matter at all. Just forget about that. Okay, why we are saying, okay, இப்போ வந்து ma'am, on the applications of Gauss's law, specifically we have taken cylindrical shape, நம்ம cuboid, and also we have taken sphere. அது என்ன ma'am? ஏன்னா we need to make it simple, right? அதுக்காக மட்டும்தான். Okay, so in the Gauss's law, Gaussian surface size, shape எல்லாத்துக்குமே வந்து there is no relevance, but definitely we have to consider a Gaussian surface. அந்த Gaussian surface குள்ள இருக்கிற charge ஓட value தான். Okay, the charge enclosed in the Gaussian surface தான் actually வந்து நம்ம what to say நம்ம flux ஓட value. Okay, yes, 50 more likes guys. Thank you Manju. Okay, so right now we have to study some of the electric field for different cases as well. First வந்து நம்ம long wire தான். Okay, இந்த மாதிரி ஒரு long wire இருக்கு, infinite தான். Okay, so இதுக்கு வந்து I cannot measure the length. இப்போ வந்து இந்த ஒரு point if I wanted to find the field, okay, அப்படினா you can just directly use this equation, lambda divided by 2 pi epsilon naught r. Tell me what is r. Tell me what is r. Quickly tell me what is r. What is r? Everybody should tell me what is r. R na ma'am simple. Okay, இது வந்து நம்ம what is infinite wire இல்ல ma'am. இந்த infinite wire ல இருந்து I should draw a perpendicular towards the point I need to find the field. Okay, இந்த ஒரு பாயிண்ட்ல தான I need to find the field. So இந்த the infinite wire ல இருந்து I will draw a perpendicular, and the perpendicular radius Greshma Hamzini radius okay, so அந்த perpendicular ஓட value தான் actually வந்து அந்த perpendicular ஓட value தான் வந்து இந்த r, which means இதுதான் வந்து நம்ம infinite wire. இங்க தான் வந்து field find பண்ணனும்னா this is what r. Understood? So now tell me what is lambda? Lambda na ma'am linear charge density. What is linear charge density? Charge per unit length. So one dimensional objects ku ellame vandu you will use linear charge density. Appadina tell me what is sigma? Sigma na ma'am very simple, q by a, the charge per unit area. Appadina tell me what is rho? Adu vandu neenga da solla porom. What is rho? Everybody tell me what is rho? Tell me everybody. Quick up. Tell me. Why no response is coming? What happened? Quickly, suddenly what happened? Yes, very good, very good. We will be getting Q by V. Understood everybody? Please let me know guys. Please let me know till this understood. Please let me know guys. Okay. So now another thing. We have to find it for the plane sheet. That expression was sigma by 2 epsilon naught da. And for a spherical shell consider பண்ணும்போது spherical shell na enna? Spherical shell na nothing inside. Okay, இதுதான் வந்து நம்ம ஷெல்னா இதுக்குள்ள எதுவுமே இல்ல, மாஸ் வந்து இல்ல. சோ மாஸ் இல்லனா எப்பவுமே சார்ஜ் வந்து சொல்லும்போது மாஸ் இருந்தா மட்டும் தான் சார்ஜ் இருக்கும். Okay, mass இருந்தா மட்டும் தான் charge இருக்கும். So definitely what will happen, inside mass இல்ல, so definitely charge கூட இருக்காது. அப்படினா நம்ம field வந்து inside it will be coming as 0. Next வந்து நம்ம surfaceல சொல்லும்போது q by kq by r square da. What is capital R? அது வந்து radius of this spherical shell da. And outside சொல்லும்போது it will be kq divided by r square it will come. What is small r? நம்ம Gaussian surface இப்போ வந்து இந்த பாயிண்ட்ல தான் field consider பண்ணனும்னா I should consider a Gaussian surface including that point. So definitely this is going to be number small r. Understood everybody? Give me a yellow heart if you understood. Everybody should give me a yellow heart. Everyone. I wanted to see how many of you understood, how many of you are still struggling. Yes. So இப்போ வந்து next topic என்னன்னா நம்ம potential தான். Okay, நம்ம potential. So tell me what is potential? Potential na ma'am very simple தான். Okay, இப்போ வந்து infinity ல இருந்து ஒரு unit charge வந்து if you are bringing to a very close point of a source charge. Okay, இங்க வந்து எனக்கு ஒரு charge இருக்கேன் Q. அப்படினா infinity ல இருந்து ஒரு unit charge வந்து if I am bringing closer to this which at a distance r. Okay, so I'm just bringing a unit test charge from infinity to this point. I should do some work, correct? இப்போ வந்து இங்க இருந்து இந்த charge வந்து I should bring it here. I should do some work. And the work done per unit charge is actually the potential. So V will be equal to work done per unit charge. Understood everybody? Everybody understood? And due to a point charge, okay, due to a point charge, this will be coming as KQ divided by R. Okay, Q na nama source charge da, and R na wherever you wanted to find the field, wherever you wanted to find the field, adu vanda you can just add. Got it everybody? Yes or no? Please let me know guys. So right now we understood about the potential. Now my question is, okay, இப்போ வந்து இங்க வந்து Q1 இருக்கு, இங்க வந்து Q2 இருக்கு, இங்க வந்து Q3 இருக்கு, and here is the point P. Okay, so this is R1, this is R2, and this is R3. Now I wanted to know the potential at the point P. Can you please let me know the answer for it? The potential at P. What will be the potential at P? Due to Q1, what is going to be that? KQ1 divided by distance plus due to Q2, KQ2 divided by R2, and here it will be KQ3 divided by R3. Till this understood everybody? Please let me know through a heart everybody. Yes or no? So we will be, if you need to find the net potential, now you will find the individual potentials and you will be just added to it. இப்போ வந்து எனக்கு இருக்கிறது இங்க வந்து ஒரு -Q4 இருந்துச்சுனா what will be the change which is going to happen here? What we need to add? Can you please let me know? Can you please let me know? இப்போ வந்து எனக்கு வந்து ஒரு -Q4 இருந்துச்சுனா I should say -K into Q4 divided by R4 should come. Okay, why? ஏனா potential வந்து ஒரு scalar quantity da. Okay, potential வந்து it is actually a scalar quantity da. So definitely very good Joshua, we have to consider the negative sign. Next வந்து we have discussed about the field இல்லையாடா, நம்ம dipole நால dipole minus q plus q, இதுல இருக்கிற field வந்து we have discussed, it is nothing but kp by r cube into root of 3 cos square theta plus 1. In the madri I just wanted to know at any point I need to know the potential. So you can just go for this equation kp by r square cos theta. Okay, kp by r square cos theta. So tell me now, what is going to be the potential at the axial point? What is the potential at the axial point? Quickly let me know. What is going to be the potential according to this equation? Tell me what is going to be the potential at the axial point. Theta will be 0, ma'am. So definitely kp by r square it will come. Now tell me what for equatorial? What for equatorial? Quickly let me know. What is for equatorial? Everybody should tell me. At the equatorial point, what will be the potential? Everyone should say. It will be 0. Very good. Very good. Very good. Kamachi and Soumya, Jahi, Manju, Maha. Very good. Very good. So we will be getting at the equatorial as 0. Till this understood, guys? Give me a white heart if you understood. Now we are going for the very important relation connecting number potential and field. In the order relation is very important. Electric field and the potential is connected by the equation E is equal to minus dV by dr. The potential is given as like this. Okay, 3x square plus 2. You have to find the field. How you will be finding it? You will go for dV by dx, which will be giving you 6x. Okay, so what is the field? Can you give me the answer? Can you give me the answer? What is going to be the field? Field will be minus 6x. Understood everybody? Everybody understood? If the field is given, you have to find potential. How you will be doing it? You will be going for E dot dr. Integral பண்ணும்போது you will be getting delta V. So this expression is very, very important. You guys have to study. There is no other, we cannot escape from it. That's it. Okay. Purinjidada everybody? Yes or no? Please let me know. Please let me know. And tell me what is the relation connecting potential energy and potential. And the two terms are difference in. Guys, marakama like, okay. So tell me, in the potential and number potential energy, there is a relation. What is that? What is that? If we have mentioned no, potential na work done by charge da. If the work done is by electrostatic force. Okay, work done by, yes. Potential is the negative gradient of electric field. Exactly. Okay, I think you still remember that. Perfect. Okay. Like button odenga guys. Odenga which means break. Something like that. Yes or no? Yes. So, our potential is W by Q. What is W? If our work done by electrostatic force. And note every time I used to write this, this physics major concept. Okay, you can use this anywhere. Okay, so the work done against any conservative force is stored as the potential energy. So can you just give me, okay, according to this statement, can you give me the expression for electrostatic potential energy? Okay, now generalize. I'm just generalize what is potential energy. Now specific electrostatic potential energy da theriyum. What is going to be that? The work done against electrostatic force. In the case conservative force na electrostatic force da. So work done against electrostatic force is stored as the electrostatic potential energy. I can say that our potential energy or expression is nothing but minus work done by the electrostatic force. Potential will be, I could say that minus W instead I am going to write the potential energy divided by the charge. Potential energy will be coming as Q into V, or else we can just go for Q into delta V. Okay, everybody understood? Please let me know. Everybody, please let me know quickly. Let me know. Everybody. So now we are going for the dielectric part. Okay. So what is dielectric? That is the insulators. And the insulators, always we won't say insulators. So why we are giving a new name for it? So that's your reason. So tell me now, what is the difference between dielectric and insulator? What is the difference between dielectric and this insulator? Very simple. இப்போ என்கிட்ட இருக்கிறது ஓகே என்கிட்ட இருக்கிறது இந்த வாட் இஸ் என்கிட்ட ஒரு dielectric இருக்கு insulator இருக்கு. I'm just placing both of this thing in an external electric field. Okay, what I'm doing, இப்போ எனக்கு இருக்கிற இந்த dielectric and இங்க I have an insulator. If I am placing this into the external electric field na, this will be get polarized. What is this? இது dielectric. I have mentioned dielectric only, right? Okay, so the dielectric will be get polarized and நம்ம insulator external field இருந்தா கூட it won't be get polarized. புரிஞ்சுதாடா? So right now I can say that the major difference is nothing but dielectric will be polarized when we are placing in an external field. Okay, that is what the first important statement. Another important statement is regarding this is nothing but, okay, I too forgot, I lost the connection. I don't know where I am right now. Okay, what we were discussing? Yes, dielectric. Okay, so we have two types of dielectric. Polar and non-polar. So polar சொல்லும்போது அதுக்கு permanent dipole moment இருக்கும் and non-polar சொல்லும்போது அதுக்கு permanent dipole moment இருக்காது. ஏன்னா அவங்க they are very close. Okay, இந்த positive and negative charge இப்படி தான் இருக்க போகுது. அப்படினா what will happen? நம்ம distance of separation 0 தானா? So இந்த 0 நால dipole moment 0. Okay, in case of the non-polar dielectric. And a polar will be like, okay, இது positive na, negative கூட கொஞ்சம் difference இருக்கு. இந்த what is the distance of separation இருக்கு. Okay, very good Srimuki. Polar na permanent dipole moment, non-polar na zero dipole moment. This is what the thing. அப்படினா நம்ம polarization ஓட expression நம்ம electric susceptibility into epsilon naught into the external field தான். And இதுக்கு வந்து இந்த ஒரு expression கூட you have to study. நம்ம dielectric constant na, which is also equal to நம்ம relative permittivity, which is also equal to 1 plus the susceptibility, electric susceptibility. புரிஞ்சுதாடா? So right now relative permittivity na, which is in terms of electric susceptibility, we can say 1 plus chi E. Okay, and also you can go for, okay, relative permittivity na enna? Relative permittivity na enna? It is nothing but the permittivity in the medium divided by the permittivity in vacuum. Okay va? So in the madri we can just go for the field as well. Okay, field in air divided by field in medium, adoda ratio da nama relative permittivity. Correct? Just write the equation da. Just write the equation. If on the field due to a point charge I am writing. What is the field due to point charge? KQ by R square. What is K? What is K? It is nothing but 1 by 4 pi epsilon naught Q by R square. If on the same system, if I am placing in a different medium, okay, different medium, then what will be the equation? 1 by 4 pi epsilon naught epsilon R Q by R square. And what is going to be the ratio E by E dash? What is going to be the ratio? This is what we got it over here. Okay, same you can apply in the case of capacitance. Okay, capacitance in medium divided by the capacitance in vacuum. That is also going to be number relative permittivity. Understood now? Give me everybody a purple or any kind of blue color. Everybody. So next one the, yes, very good. So next one the நமக்கு இருக்கிறது நம்ம capacitance தான். So நம்ம capacitance சொல்லும்போது first one நம்ம capacitance ஓட equation என்னடா? Q by V da. Thank you so much for the hearts. Thank you so much. Okay, it is nothing but Q by V da. இப்போ வந்து capacitance சொல்லும்போது usually வந்து we will say that we should have two conductors. Correct? We should have two conductors. Ana vandu, when I am saying about the isolated spherical conductor, which means one is here, another one I am assuming that it is at the infinity. Okay, one plate is here, another conductor is at the infinity. அப்படினா அதோட capacitance ஓட value வந்து 4 pi epsilon naught R தான். 4 pi epsilon naught R தான். இப்போ வந்து மேஜரா வந்து இந்த சாப்டர்ல we are talking about the parallel plate capacitor தான். Parallel plate capacitor சொல்லும்போது அதோட capacitance வந்து A epsilon naught divided by D. What is A? What is D? Tell me. So இப்போ வந்து two plates இருக்குல்ல, two plates இருக்கு. So இந்த plate ஓட area தான் A and in the plates இருக்கிற distance தான் D. இப்போ வந்து இதுக்குள்ள if I am placing a medium, okay, complete cover பண்ற ஒரு dielectric medium place பண்ணிட்டேனா what will be the capacitance? It will increase K times. So this will become K epsilon naught divided by D. It will come. புரிஞ்சுதாடா everybody? Please let me know. Very good, Kamachi. It will be coming as A will be area and D is the nothing but the distance of separation between the two plates. Guys, don't forget to like the session. You are observing, you are just listening the class, but you are not giving the like. That is not fair at all. So C will be equal to Ka epsilon naught divided by D. Another important statement. Very good, Rita. Very good. K into C naught. What is C naught? The capacitance in air. Okay. So actually, we know that capacitance in air, which means epsilon naught A by D. So appadina capacitance in a medium which is having a dielectric constant K na, I could say K C naught. Okay. And we have mentioned C naught by C. What is that? We have mentioned no. It is nothing but K. புரிஞ்சுதாடா? So next வந்து I'm not going to fill it completely. Okay, எனக்கு வந்து இந்த dielectric medium வந்து complete fill பண்ற தேவையில்லை. Okay, அப்படினா definitely I am just placing, okay, just listen here. I'm just placing it for a very small thickness. Let me say T. அப்படினா இங்க வந்து பாக்கும்போது நம்ம capacitanceல கூட difference இருக்கு. அந்த difference வந்து explain பண்ற equation தான் C is equal to epsilon naught A. And the top portion la there is no confusion. Ana vanda when it comes to the denominator, it will become D minus T plus T by K. It will come. Understood everybody? Please let me know, guys. Everybody, please let me know. So what I was saying, the capacitance which is equal to epsilon naught A divided by D minus T plus T by K. What is T? Nama dielectric medium thickness. What is small t? What is small t? Everybody tell me. What is small t? Nama dielectric medium okay. Dielectric medium thickness. Don't forget. Okay. And what is D? What is small d? It is nothing but nama distance of separation between the what? Everybody tell me. Okay? Done? Tell me everybody. Okay? So now we are going for the capacitance we are going to connect in different patterns. Okay? Series and parallel. So what will be if it is in series? Okay, so the capacitance is added in series. Now, how we will be finding the capacitance, equivalent capacitance? Can you please let me know? Ma'am, adu on the board why we should type everything? Simple ma'am. It will be 1 by C equivalent, which is equal to 1 by Z1 plus 1 by Z2 plus etc. 1 by Cn. If the capacitance identical na, okay, all capacitance, n capacitance connect pannirukken. ஆனா எல்லாமே identical. அப்படினா what is going to be the equivalent capacitance? If I am connected n capacitors in series mode na, what is going to be the equivalent capacitance? It will be C by n. அப்படினா if I am connecting in parallel, then it will be C1 plus C2 plus C2. It will go like this. Ana tell me if n identical capacitors now, if I'm connecting in parallel, what is going to be the C equivalent? Very good, Rita. Very good, Jahi. Very good. So now tell me the answer for this one. Very good, Jahi. It will be n times the capacitance. Understood, everybody? Yes or no? Give me a heart if you understood. Any your favorite heart you can give me. Everybody. Yes, perfect. So now we are going for the energy stored in the capacitor. Energy stored in the capacitor it will be half CV square. Illana C you can replace. Illana V you can replace, and you will be getting 3 different equation. Q square by 2Z, or else you can go for half into QE. Depending upon the question. Okay, in the question what are the given data? Okay, what are the given data? You can just check it and you can just apply. Now energy density na nothing but the energy per unit to volume. Okay va? So other expression half into epsilon naught E square if it is in air. If it is in a medium, we should multiply it with K. Okay, so study this equation also, very important. Energy stored equation question based questions we can expect. Understood, Dada? Everybody? And let me tell you one more important thing we have done with this chapter. Happy? Everybody? Everybody tell me, are you happy? Okay, so quicker we have discussed, and in the upcoming class, I think on the next Thursday or something, we will be going along with the questions on the session. Marakam attend panikoda. And on the concept you have studied from here, right? Okay, either on the application level questions in the what is it? You are not just supposed to study one few equations and other in the 100% mark it is not possible. The question practice is very important. So on the session you guys have to attend. Okay, everybody ready for the current electricity? Now give me your favorite heart. Everybody, if you are ready for current electricity, give your favorite heart. Everybody. So 67 minutes we have done 2 chapters. Great. Yes. So without a favorite color was the pink. Jehi purple. Sri Varshini purple. Angelin's favorite is the sky blue and white, right? Yes, Kamachi yellow and red. Yes. Yes, Gia pink again. Oh my god, it's gone. So I'm not getting it. Okay, fine. Okay, so let us just start with the current electricity. First on the current electricity, we will go for current. What is current? Charge or flow. So definitely the expression current it is nothing but equal to Q by T. If I'm asking about the instantaneous current, okay. If I'm asking Samiksha, okay. My old Samiksha, last class winner Samiksha. Am I right or wrong? Tell me. Okay. So if the instantaneous current it will be coming as dq by dt. Now I'm going to ask you a question. If I am floating, okay, this charge was this time. Okay, charge versus time. Yes, okay, Samiksha. Okay, so charge versus time. What is the slope? What is the slope of this? Tell me, everybody. And also, I'm going for another one. I into T. Okay, so tell me what is the slope of this case? What is that? dq by dt. What is dq by dt? It is nothing but current. Now tell me, what is the area under this curve? What is the area under the IT curve? Tell me, what is the area under the IT curve? What is the area under the IT curve? Quickly let me know. What is the area under IT? Which means, let me just multiply here, I dt, which is equal to dq. If I'm integrating, what I will be getting? I will be getting the charge. Very good, very good, very good. So area under the IT graph will become coming as the what to say number charge the in the current order equation la, instead of Q I can write it as NE by T as well. Can I write it like this? Yes or no? Please let me know. Can I write it like this? Yes or no? Please everybody. So idukapram in the current mudichena first vandu we should understand about the drift velocity. What is drift velocity? Can you please let me know? In the drift velocity, ma'am, drift velocity is nothing but, let us say, இப்போ வந்து நமக்கு வந்து ஒரு கண்டக்டர் இருக்குன்னா இந்த கண்டக்டருக்கு வந்து if you are not applying any field னா இந்த கண்டக்டருக்குள்ள இருக்கிற free electrons இல்ல மேம் அது எல்லாமே வந்து இப்படி போய் random directionல it will move and average velocity பார்த்தேன்னா அதோட value வந்து what is going to be the value? Can you please let me know? What is the value? Okay, it will be coming as nama. Everybody tell me what is the answer? If you are not applying any electric field, nama conductors kulla irukra free electrons will go for a random motion and average velocity will become nama muttai da. Okay va? It will become 0. Appadina enakku vandu 0 kadakadhu, enakku vandu konjam value adhigama varanum. Appadina what I will do? I will give an external field. The external field vandu if you are giving na, what will happen? Definitely nama electrons will be moved in the same direction. Okay, they won't go for random motion. Okay, they will move in the same direction. So definitely, unknowingly ma'am itself said the answer. Okay, so definitely what will happen? Adinala it will be having, okay, and the motion nala it will be having a drift velocity. And the drift velocity or expression vanda minus EEM by tau da. So now tell me what is tau? What is tau? Everybody tell me what is tau? Tau na ma'am relaxation time. Okay, enna the relaxation time? Okay, இப்போ வந்து நீங்க வந்து if you are fighting with your siblings, right? So அந்த fight குள்ள இருக்கிற in between time இல்ல. Okay, one fight முடிச்சிருக்கு, அடுத்த fight next fight வந்து start பண்ண போறோம். அதுக்குள்ள இருக்கிற அந்த ஒரு time இல்லையாடா, that is what நம்ம relaxation time. Okay, the time between the two collisions, அதுதான் வந்து நம்ம relaxation time. So அதுக்கப்புறம் பார்த்தேன்னா நம்ம drift velocity and current வந்து கனெக்ட் பண்ற ஒரு equation தான் n into a into vd. Okay, so n னா என்னடா number density தான், a னா cross section, vd னா நம்ம current drift velocity ஓட expression தான். So next one, yes, very good Angeline, very good Sri Varshini, yes Joshua, very good. The average time between two successive collisions the actually வந்து நம்ம relaxation time. அப்படினா now my question is very good, NAVD. Okay, E கூட வேணும்டா. Okay, right now if I'm asking about current density, what is current density? அது வந்து நம்ம current வந்து we know அது வந்து scalar or vector ஆடா? Current is a scalar or vector quantity. Can you please let me know? Current is a scalar or a vector quantity. Obviously it is a scalar quantity da. Okay, current is scalar quantity da. So appadina in the scalar quantity I want in the current order ஒரு vector form வந்து எனக்கு தெரியணும். அதுக்காக இருக்கிற form தான் current density. Okay, so current density na very good. I can see Joshua and Samiksha, Jahi, very good. It will be nothing but the current per unit area da I by a da வந்து நம்ம current density ஓட expression. Very good Shalini, very good Jia. Yes, Radhika, right? Yes, hi Radhika, hi. Everybody say hi to Radhika. Radhika, right? I am pronouncing it correct, right? Yes, very good Jia, very good Rita, Sri Varshini. Yes, perfect. So that is what nama current density. Next நீங்க வந்து பாத்தேனா we have another quantity which is nothing but mobility. Okay, what is mobility? Mobility na in the drift velocity per unit time. unit field. Okay, so what is mobility? Drift velocity per, yes, Jason, I forgot your name also. I forgot. After, if there is no class for one day, I will forget everything. Why this is, ma'am? You are remembering equations, but you cannot remember names. Yes, good evening, da Elma. Right, Elma? Yes, good evening, Jason. Yes, Angeline, very good. So, it will be coming as VD by EDA. Yes, Divya and Praveen got confused. Yes. Now it is stored again. Okay, so VD by EDA. So, nama drift, what is it, mobility வந்து பார்க்கும்போது VD divided by EDA. VD on the expression we know EE by M. Tau. So divided by E. So I'll be getting another expression for nama. What is the quantity? Mobility. Okay, so mobility we got another expression which is nothing but E tau by M. So next nama Ohm's law. Okay, can you please let me know what is Ohm's law? What is Ohm's law? Everybody tell me what is Ohm's law. Very simple, ma'am. 10th grade we are studying. Okay, we are pro in the Ohm's law. So tell me now, what is Ohm's law? எப்பவுமே வந்து நம்ம physical conditions, நம்ம temperature எல்லாமே வந்து constant இருந்துச்சுனா, நம்ம potential will be always proportional to current தான். இப்போ வந்து if I'm increasing the potential 2 times na, current will also increase by 2 times. Very good, Rita. Very good, Jehi. So right now my question is இப்போ வந்து என்கிட்ட I have a graph like this. What is the slope? What is the slope? Tell me, everybody, what is the slope of an IV graph? What is the slope of an IV graph? Let me see who all are the pro in what is it? Ohm's law. Yes, 29 more likes, guys. Don't forget to like. Pro people are giving the wrong answers. I can't just cycle this. I can't. This is very good. Tanu. Yes, it will be I. Correcta. Slope na enna? இங்க வந்து பார்த்தேனா delta I divided by delta V da. What is delta I by delta V? Tell me. That is nothing but 1 by R. Correcta. So I by V will be coming as 1 by R da. V by I da actually வந்து R. புரிஞ்சுதாடா? Everybody understood? Give me a white heart if you understood this one. Simple ஒரு concept. We are studying from our small grades. Still we are making the mistake. I don't agree with this. Okay. So right now let me give you one more question. So இது வந்து A. This is what B. This is what VI. So which material, A or B, which one is having the more resistance? Which one is having more resistance? எனக்கு வந்து two materials இருக்கு, A and B. So இதுல வந்து you have to tell me which one is having more resistance. Tell me quickly. So definitely ma'am, இது வந்து VI da. So VI, இதோட slope வந்து V by I da. V by I know that it is R. So definitely slope which is having more slope, அதுக்கு தான் வந்து very good. So we will be getting in the case la B da வந்து right answer. இப்போ வந்து same question I'm asking in a different way. Okay. So இங்க வந்து பார்த்தேனா I da, இங்க வந்து V da. So this is material A and this is material B. Which one is having the more resistance? Which one is having more resistance? In the case, tell me which one is having more resistance. Which one is having more resistance? Tell me, A or B? Very good, Angeline. It will be having. Okay, நம்ம A ஆகுதா? ஏனா இதோட slope வந்து I by V da, which means 1 by R. So if it is slope, okay, if the slope is very small na, resistance is going to be very high. So slope வந்து கம்மி for A da, so definitely I could say that resistance will be more for A. If you understood, give me a green heart quickly, then we are going for the next set of concept. Okay, so right now we have studied one thing, nama Ohm's law, which is nothing but V is equal to IR da. Now I wanted to know இதோட vector form. What is this vector form? Vector form வந்து J is equal to sigma E, or otherwise I could go for E divided by rho. ஏனா வந்து sigma is equal to 1 by rho. புரிஞ்சுதாடா everybody? All these relations are very important. Now I'm going for the another concept which is nothing but about our resistance. So when I'm talking about resistance, okay, let me take a breath. Okay, so now we are going for the resistance. In the resistance path, it is depending upon few factors. What are the things? What are the things? The resistance depends upon the length of the conductor. It is also depending upon the area of the conductor. It is also depending upon the material. It is also depending upon the temperature. So resistance சொல்லும்போது it is depending upon these many factors. So I can form an equation which is nothing but rho into L by A. Okay, so which means length increases now. So when I'm talking about, very good Samiksha, very good Joshua. So when I'm talking about this resistance illada, length increases na. So basically you should understand resistance na, it will oppose the flow. கரெக்டா? இப்போ வந்து length அதிகமா இருக்குனா definitely more collisions. இப்போ நீங்க வந்து you are traveling, okay, you are actually walking in a very rush speed, okay, அங்க வந்து many people are there, okay, lots of free electrons are there. அப்படினா நீங்க வந்து if you are going na, you will definitely collide with many people, right? Okay, ஏனா length வந்து increase ஆயிருக்கு, so definitely நீங்க வந்து collision கூட it is going to be more. அப்படினா the current na, it is nothing but நம்ம flow of charges da. In the charges will go for more collision na more resistance. இப்போ வந்து suddenly what happened? I did a magic. I understood my students are struggling in the street. Okay, they cannot go for any shopping or something. Suddenly I'm just doing a magic. What is the magic? I'm just increasing the width of the road. So what will basically happen? Without collision, my students can go for shopping. My students can do whatever they want. So basically the collision will reduce. Collision reduce aachna, what is the meaning? Resistance வந்து decrease ஆருக்கு, which means you can go without much difficulty. You will be going in the forward direction. Understood everybody? Please let me know, guys. Please let me know. அப்படினா this is what நம்ம resistance ஓட expression. இப்போ வந்து I just wanted to know about the resistivity ஓட expression. Okay, resistivity ஓட expression is also very important. M divided by NE square tau. Okay, what is resistivity? M divided by NE square tau. So using this equation only, we are talking about the how with the temperature, how the resistivity illana resistance is actually what is it, changes. Okay, ready are everybody? Everybody ready for the temperature dependence? Now give me a heart quickly. Give me a heart quickly if you are ready for it. Everybody, yes, of course Elma, நீங்க வந்து கொஞ்சம் லேட்டா இருக்கே, but பரவாயில்லை, you can also attend from here. Okay, we are almost half finished for current electricity. Then we will go for the next chapter. So நம்ம வந்து we have discussed நம்ம resistivity ஓட expression வந்து mne square tau da. So இதுல வந்து பார்த்தேனா first வந்து you should understand the temperature dependence of the resistance. So the temperature dependence க்கு வந்து you can study this equation at any temperature. Okay, at any temperature the resistance RT will be equal to initial resistance into 1 plus alpha delta T. What is alpha? Number temperature coefficient. Okay, in the alpha value will be positive 4. Can you please let me know? In the alpha value will be positive for the conductors. Okay, so that is what the important thing that you should understand. So right now we have studied rho is equal to M by NE square. Now first let me discuss about the conductors. How the conductors in the equation that is true. So let us just discuss on the basis of or how we have derived that equation. Adoda reason that actually we are going to be the ma'am is the first chapter or any other chapters you completed already. Electrostatics completed, current electricity is going on. Okay, next one the magnetism. So rho which is equal to M by NE square tau da. So conductors சொல்லும்போது அதுல வந்து நீங்க வந்து பார்த்தேனா இந்த M N E square எல்லாமே வந்து constant தான். ஆனா வந்து when I'm giving temperature, okay, I'm giving more temperature for a conductor. What I'm doing? I'm giving more temperature for the conductor. So logically, don't think about anything. I'm just asking you, temperature increase aachna, what will happen to the what will happen to the relaxation time? Tell me the answer. Okay, temperature increases. Okay, what will happen to the free electrons? Adoda collision time வந்து will it increase or decrease? So definitely you will get to know in the collision time வந்து decrease ஆகும். ஏனா வந்து just understand நீங்க வந்து you are not even had anything. Okay, the whole day you are not having you didn't had anything. உங்க energy level வந்து கம்மி தான். அந்த ஒரு டைம்ல your brother or your sister is coming and try to get into a fight. So definitely what you will say, you will ignore, correct? ஆனா வந்து நல்ல எனர்ஜி இருக்கு. Now your sibling is triggering you. What you will do? You will immediately go for the fight, right? So exactly the similar way, when temperature increases, in the free electrons வந்து extra kinetic energy கிடைக்கும். Okay, extra kinetic energy na நம்ம collision வந்து இன்னும் fast ஆகும், which means நம்ம relaxation time, okay, two successive collision குள்ள in between இருக்கிற அந்த ஒரு time ஓட value வந்து decreases. So இது வந்து decrease ஆச்சுனா what will happen to நம்ம resistivity? It will increase. Okay, resistivity will increase when the temperature increases. In the case of conductors, understood? Give me a white heart. Everyone should give me a white heart if you understood about the conductors. Now we are going for the semiconductors. Everybody tell me. So right now we are going for the semiconductors. Okay, so in the semiconductors what will happen? So semiconductor pathena, again I'm just writing this equation, m divided by n e square tau. So nama what is the semiconductors la in the m oda value e square tau idellame vandu almost constant da. Why I am not considering tau na, நம்ம conductors விட இந்த semiconductor பார்த்தேன்னா அங்க free electrons ஓட numbers வந்து கம்மி தான். So relaxation timeல கொஞ்சம் change இருந்தா கூட that will never reflect much. So definitely we know that when temperature increases, the covalent bond will break, more number of holes and the free electrons will be formed. Okay, so அப்படினா இந்த n value will increase, correct? Temperature increases in case of semiconductors na, covalent bond will break. Covalent bonds break achna, what is the meaning of that? Definitely more number of charge carriers formed, holes and the what to say nama free electrons vande it is going to be more. Appadina n increases, so obviously resistivity is going to reduce. Understood everybody? Give me your favorite heart if you understood. I can't see the energy right now. Only I have the energy. You people have less energy. I'm not coming to fight with you now. Okay, I'm not your sibling. Okay, I'm not ready for any fight. So give me some energy. Yes. So right now we are going for the resistors or a combination. So if it is in series, tell me, if resistors are connected in series, what is the equivalent resistance? In series now, R1 plus, R2 plus, R3 plus, etc. If it is identical, what will happen? It will become n times R. Now another thing is like parallel combination. Parallel combination சொல்லும்போது it will be coming as 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus etc. 1 by R. If it is identical, definitely it will become R by N. Just exactly opposite to whatever we have studied in the what namma capacitors. Okay, so that is what the another important thing. Now tell me namma electrical energy or equation. Okay, by heart. Okay, simple an equation la electric energy. Another expression and we know that it will be coming as VIT, or otherwise we can go for I square RT, or otherwise we can go for the V square by RT. If I'm asking you to find the power now, what will happen? You will just remove the time term here, right? Yena vande energy by time da nama power oda value. So that is what we can see here. Okay, electrical energy and the electrical power oda expression. You guys have to study all these equations. Done everybody? Please let me know. Let us go for the cells EMF. Ready? And the topic mudichana, we don't have much things to discuss in the current electricity. Quickly. Neha, these are also for NEET 2027. Already நம்ம channel videos இருக்குடா. You can just watch it. You can start watching it. நம்ம Re-NEET முடிச்சதுக்கு அப்புறம் தான் we will go for NEET 2027 டா. ஏன்னா வந்து ஆக்சுவலா வந்து சொல்லும்போது நம்ம ஸ்டூடெண்ட்ஸ் வந்து they trusted us very well. Okay, அதனால இந்த லாஸ்ட் மினிட்ல we cannot just say we can't help you. நம்ம NEET 2027 ஸ்டூடெண்ட்ஸ் இருக்கு அந்த மாதிரி சொல்ல முடியாது. So that is the reason. So you can just already watch the videos. அங்க எல்லா வீடியோஸ்மே இருக்கு, எல்லா சாப்டர்ஸ்க்குமே வீடியோஸ் இருக்கு. You can just watch it. And in the Re-NEET முடிச்சதுக்கு அப்புறம் நம்ம 21st க்கு அப்புறம் we will just start the 2027. I promise you, Neha. Okay, so now we are going for the another thing which is nothing but number cell EMF and the internal resistance. So first what I wanted to know is I wanted to know about the equations, so definitions. What is the cell? Chemistry you have studied. What is cell? Tell me. Balaji, hi. Tell me what is the cell? Cell it is nothing but a device which will be converting chemical energy into the, oh my god, heart. Shamita, keep it with you da. I don't want anyone's heart. Okay, I want only that this heart. Okay, so right now, what is a cell? It is a device which will convert the chemical energy to the electrical energy. So next one is EMF da. EMF na very good rita. EMF na again இன்னும் simple அதா இருக்கு மேம். So இப்போ என்கிட்ட ஒரு circuit இருக்கு. அந்த circuit it is just with the cell மட்டும் தான் இருக்கு. அது ஒரு open circuit. ஏனா current it is not flowing. Okay, current ஓட value என்ன 0 தான். அந்த current ஓட value, if there is no current flowing in the circuit, அந்த ஒரு டைம்ல இந்த cell across, I'm just checking what is the potential difference. அந்த value தான் EMF. Okay, very good Balaji. If there is no current, if I'm checking the potential difference across the cell, it will show the EMF, electromotive force. Okay, Vada. Now another thing is what is terminal voltage. Terminal voltage, I have connected an external resistance. அப்படினா அந்த external resistance definitely there will be a flow of current, which means in the time current zero it is actually a closed circuit. Current is actually flowing. Okay va, current is actually flowing. அப்படினா அந்த ஒரு டைம்ல I could say that I am just checking what is the potential difference across this cell. அந்த டைம்ல if the current is flowing na, that time whatever I am just measuring அதுதான் terminal voltage. Okay, that is what the terminal voltage. So in the three terms irukku, cell, EMF and the terminal voltage. Another important term is nothing but internal resistance. Internal resistance, now we know that if in the current, okay, in the circuit closed na, the charges should flow, right? Okay, so externally it will flow. Now I am talking about what is happening internally in the cell kulla. Definitely in the charges should pass, right? அப்படினா இந்த செல் பார்த்தேனா அங்க electrodes இருக்கு, anode இருக்கு, cathode இருக்கு, electrolyte இருக்கு. அப்படினா what will happen da, நம்ம charges will flow through the electrodes, அதுக்கப்புறம் electrolyte. So during this journey it will experience some resistance. Okay, in the resistance is not because external circuit, இது இந்த செல்லுக்குள்ள happening. Okay va, so adinala in the electrons will flow inside the, okay, electrons will flow inside the circuit. So andha oru time illa inside the cell electrolyte and this electrolytes ellame it will oppose the flow of charges. Andha oru time illa irukra resistance the internal resistance. Understood da? Yes. EMF na current, there is no current flow. Okay, current flow illana what is happening? Nama internal resistance edho affect pannadhu. Andha time illa irukra potential difference. Okay, adha nama EMF. Purinjada everybody? If you understood, give me a white heart. Everybody quickly give me a white heart. Everybody, I want white heart. I'm starving for white heart. Okay, so ipo neenga paathena nama paakumbodhu, if it is a circuit like this. Okay, if it is a circuit like this, idhula internal resistance irukum, and I'm just connecting an external resistance also. This is what R, this is what small r, this is what number EMF. Okay, if it is open, what is that? If I'm calculating the potential across this cell, idu EMF da. So right now what happening? So right now during the time of discharging, okay, during the time of discharging, what is exactly happening da? So nama EMF is utilized. Okay, so actually whatever I'm giving you, you guys have to take it completely. Okay, enga kitta 10 apples irundichna, you should take all the 10 apples. Appadina engitta irukkiradhu EMF da. So this will be utilized by two people. Who are the two people? Can you please let me know? In the EMF will be utilized by two people. One is this external resistance, one is this internal resistance, and current which is flowing is, let us say, I da. So I can say that the potential drop across this one, which is nothing but IR, plus the potential across this, potential drop across this one will be I into small r. So I'll be getting E is equal to IR plus B. So what is this IR? What is this IR? The potential, the terminal voltage. So I will be getting the expression for EMF like this. Understood that everybody? Please let me know, guys. Please let me know. This is in the case of discharging. And sometimes we used to charge the battery as well, which means while we are just connecting mobile, charging, right? So on the time, what is the condition? If the charge should flow from the external to the cell, what must be the condition? The potential should be high over here. Okay, so definitely terminal voltage should be high. Okay, during the time of charging, if the charger should flow higher potential it should have, which means terminal voltage mattu, if it is higher than EMF mattunda in the charge flow will happen. Understood everybody? Please let me know through a green heart. Give me a green heart, everybody. Yes. So now we are going for the combination, which is very important. So now cells in series. Okay, series if you are connecting the cells adoda current order value it will be N times the EMF divided by R plus N into R. So the thing is like inga irukra cells ellame identical da. Okay, inga irukra cells ellame identical da. If it is parallel, then it will become ME divided by M into capital R plus R it will come. And if it is having two different cells, okay, identical I have two cells which is connected in parallel I will be getting the equivalent EMF like this, E1 R2 plus E2 R1 divided by R1 plus R2. Whether it is internal resistance, external resistance, number resistance is the number parallel and series circuit, whatever be the equations we are using, use so inga cell it is connected in parallel, so two internal resistance connected in parallel, so the equivalent resistance will be coming as R1 R2 divided by R1 plus R2. Guys, don't forget to like the session, everybody. Everybody like the session, don't forget. So next one the mixed duping da. Okay va? So actually N cells nama series la connect pannirike. M cells we are connected in parallel. Appadina nama current order expression will be coming like this. So you guys have to note down all these equations. Over equations very important, and idu derive pandradhukku we don't have time da. So definitely you guys have to note down each and every equation I have mentioned over here. If the question kadachena moment you can just write this equation, substitution only left, that you can do, done. Okay va? Everybody understood? Please let me know. And guys, you guys are not giving the likes. I don't know why. So next we will be going for the Kirchhoff law. So before me, I know you people will be giving the answer for Kirchhoff law. What is Kirchhoff law? First law, nama junction rule. Okay, nama junction rule. What is junction rule? What is junction rule? The current entering into the junction will be equal to the current leaving the junction. Appadina in question in the junction total current order value. Now I1 coming, I2 and I3 is leaving. So now tell me what is the current at the junction? Very good, Angeline, very good. What is the equation? What is the current in the, I have given up, sorry. Okay, the sum of the, what I'm saying and whatever I'm writing is completely different. Okay, so I was asking this question, the sum of the current at the junction will be coming as nama motte. Okay, and I could also say I1 is the current entering, it should be equal to the current leaving, which means I2 plus I3. Purinchidada everybody? Guys, don't forget to like the session, everybody. Okay, next one the nama voltage rule da. What is voltage rule? If we are considering, okay, if you are considering a closed loop, okay, if you are considering the closed loop, and the closed loop change in potential or sum eppavume again it will become nama. Okay va? So two rules two laws first one the junction, second one the loop rule da. Junction la we know that current entering, current leaving will be same, which means at the junction it will be 0. Next one voltage la closed loop la sum of potential difference will be coming as 0. And now the another thing which you should study is இப்போ வந்து the junction rule na adula வந்து what actually it is based on law of conservation of charge da. Why it is so? ஏனா வந்து the charge which is entering into the junction should be equal to the charge leaving the junction. So total charge should be always conserved. Total charge will remains the same. So அப்படினா I could say that it is based on the conservation of charge. When it comes to voltage law it is based on conservation of energy da. இப்போ வந்து I'm connecting it with a battery. Okay, I'm connecting it with a cell. So I'm giving some potential, right? Okay, and whatever I'm giving, that is what I have mentioned. இப்போ நான் வந்து 10 apples I'm giving you na, definitely you people have to take it. Okay, 10 apples should be utilized. Which means if I'm giving a 12 potential as to the closed circuit na, in the 12 potential should be utilized by the members in the circuit. Okay, so which means 12 if I'm giving, the voltage drop through across each and every component should be equal to 12 volt. Understood? Okay, so Elma, that will be done in the upcoming marathon session. This is just we will be discussing the concept only da. Purinjidada? Okay, so that will be done. We will be doing in the marathon session. So just wait for it. Done, everybody? Please let me know. Everybody, please let me know, guys. Yes. So now we are going for the measuring instruments. So first one வந்து நம்ம Wheatstone bridge தான். Wheatstone bridge is actually based on நம்ம Kirchhoff law based பண்ணி தான் இந்த Wheatstone bridge is actually working. So அதோட balanced condition na, it is nothing but நம்ம resistance ஓட ratio should be same. In the same concept use பண்ணி தான் we are actually working on the meter bridge as well. So in the resistance, in the R and S வந்து we don't know. Q also we don't know na. R and S. Okay, எனக்கு தெரியறது வந்து 1 resistance P value எனக்கு தெரியும். Okay, R and S எனக்கு தெரியாது. And I wanted to find Q. இந்த மாதிரி ஒரு questionல we will be using this meter bridge. So how this is working? So we know that நம்ம வந்து இந்த meter scale இருக்கு. 1 meter lengthல நம்ம scale இருக்கு. So இதுல இருந்து 1 pointல இருந்து we will move the jockey. At some point what will happen? நம்ம galvanometer will show a zero deflection. So on the time we know that resistance is proportional to length. So whatever be the length coming, I can just replace the resistance with the length. So that is the total length வந்து 100 centimeter தான். So I'll be getting 100 minus L by L and R value வந்து எனக்கு தெரியும். So S value வந்து உங்களுக்கு find பண்ண முடியும். Understood everybody? Yes or no? Please give me a white heart everybody. Everybody give me a white heart. So can we go for the next chapter ready? Before that, should we go for a very small break of 5 minutes? Even I need a small break, a 5 minutes break. 3 chapters mudichirike. In 100 minutes we have done 3 chapters. Okay, so let us go for a very small break. When you guys can come back, please let me know. I know that it will affect a little bit, but still. Again, if you are just continuing without break, it is going to be very difficult for you people. Okay, so let me know. 6 o'clock, everybody's ready? Yes, perfect. So let us resume at 6 p.m. and likes target 150 plus. Okay. And also we will continue with magnetism. So see you guys. We will meet at sharp 6. Everyone should come. Okay, promise me everyone will come. Promise me, quicker promise me. Okay, everyone should come and we will just continue with the magnetism and all the chapters. I think each of this the session when the useful arke I feel so. So everyone should come back. We will just continue after some time. Thank you, Samiksha. Thank you. Pinky promise. Okay, I'll see you. Hello, everybody. Are you guys here? Give me some fire if you're ready for the magnetism. Everybody. So yes, so actually வந்து நம்ம again நம்ம description box பார்த்தேனா நம்ம second link இருக்குடா நம்ம get நம்பிக்கை Re-NEET 2026 AITS All India Test Series அந்த ஒரு லிங்க்ல கிளிக் பண்ணிட்டேனா you will be directly going into the Amazon app. Okay, so Amazonல you will be getting almost 2500 questions. Yes. Okay. So actually in the 2500 questions order or a book if you want it, you will be get it for 549. Again, you know that hardly the 20 days in the 20 days how much important is to solve the questions. It is very, very important. You cannot even say that ma'am, I will study the concept questions, let it be definitely you are going to get a very bad result. Okay. Apply content library, it is not showing the actual some technical issues were there, so we will sort it out and we will get to, we will let you know when it will be available and all the details I will share. Okay, don't worry. So this is what the thing, if you want it, you can just go for the second link. Okay, second link is 549 rupees. You will be getting the this book along with the 20 OMR sheet. You know, the next 20 days you have to practice more questions along with the OMR. Now you can just go for a proper mock test. Okay, keeping the time limits and everything, you can just go for it. This will be very much beneficial for you. So if you want it, you can just go for it. If you are ready for the magnetism chapter, right now itself, you should give me a green heart. Green heart. I want to see green heart. A green forest should come. Okay. So let us see. How many green forests will come? Let me see. Yes. So right now we are going for the magnetism chapter. In the magnetism chapter, first we should understand the magnetic force. Okay. Nama Fm. Okay, magnetic force. What is the expression? What is the expression? It is nothing but Q into V cross B. Am I right or wrong? It is nothing but Q into V cross B, which means the magnetic force is depending upon velocity. It is also depending upon the magnetic field as well. And if you need to know the magnetic force or a direction, now what we should do? Oh my God, thank you Manju. Thank you so much for this, what to say, dense green forest. Dense green forest we can see in the chat box. Yes, Mukundan. Right, Mukunta, right? Yes. Thank you, Da. Thank you so much. So right now, nama magnetic force Q into V cross B da. So if you wanted to find the magnetic force or a direction, you can go for the what? We can go for the what to say, nama right hand use pannalam, which means we will be taking the velocity or a direction, we will point our fingers. Then we will curl our fingers towards the direction of magnetic field. The thumb will give you the direction of force. Okay, ba? So this is what the this is how we can just go for it. Otherwise, now you can also go for the Fleming's left hand rule as well, which means nama magnetic force. Okay, what was the thing? The magnetic force, and then we will be having the velocity. Correct? Okay, then we will be having the magnetic field and the velocity or a direction line. Okay, ba? So this is how we will be going for the Fleming's order left hand rule. Okay, ba? So this is what the Sushmita. Okay, Sushmita. Perfect. So magnetic force, Lorentz force. What is Lorentz force? If there is the electric field as well as the magnetic field, net force experienced by the charge. Okay, the net force experienced by the charge will be coming as the magnetic force plus the electrostatic force, which means it will be Q into V cross B plus number electrostatic force, which is nothing but Q into E. So this is what the Lorentz force. Okay, so now we will be going for the another concept, which is nothing but, let us say, when there is a charge, okay, when there is a charge which is in an which is in a magnetic field, okay, which is in a magnetic field, which means I'm projecting a charge in different directions. So what all are the things will happen? So simple as solitana, first வந்து நம்ம magnetic field இப்படி தான் இருக்கு. Okay, நம்ம magnetic field இப்படி தான் இருக்கு. So let me just consider few cases, then we can discuss each in detail. Okay, so this is how it is coming. So this is the another one. So now what I'm going to say is, let me just project a charge a charge in the direction of field. Okay, so Q is actually இப்போ வந்து பார்த்தேன்னா B and V வந்து same directionல தான் இருக்கு, கரெக்டாடா? So இப்போ வந்து magnetic field and the velocity வந்து same directionல தான் இருக்கு. அப்படினா நம்ம force ஓட equation என்ன? Q into V into B sin theta. Am I right or wrong? Yes or no? அப்படினா tell me நம்ம first caseல இப்போ வந்து if you are just projecting something in the direction of field na, what will be this angle theta? What will be the angle theta? Please let me know. It will be coming as 0. Correct? V and B on the same direction. So QVB sin 0. So magnetic force will be 0, which means it won't be affected by any force. It will move in a straight line. Understood? Give me a white heart quickly. Very good, Elma. Very good, Tanu. Very good, Srivashini. Yes, I forgot your name. I forgot Mugunta. I forgot your name. Sorry. Okay, so next one, I'm projecting in the opposite direction. Field வந்து இப்படி இருக்கு, V வந்து இப்படி இருக்கு. So what is the angle? Please let me know. What is the angle, everybody? What is the angle? It will be 180 degree. அப்படினா tell me now, what is the magnetic force? What is the magnetic force? Quickly let me know. What is the magnetic force? Very good, Srivarshini. Very good, Tanu. So this will be coming as Sushmita, yes. It will be again coming as 0. Now another thing is like, I'm projecting perpendicular to the field. Okay, I'm projecting perpendicular to the field. So what is going to be the angle theta? It will be coming as 90 degree, and the force will be maximum, which is going to be Q into V into B. Okay, maximum force we will be getting when we are projecting perpendicular to the magnetic field. So when it is moving in, okay, so in the first case la straight line da, second case la kuda straight line da, ena force experience pannala. Ana vandu inga vandu pathena there is the maximum force. Okay, appadina definitely this will be going for a uniform circular motion. Okay, it will be going for a uniform circular motion. Another thing is nothing but I'm projecting in an angle. Okay, velocity inge irukke, magnetic field inge irukke, and between this there is an angle theta. So obviously what will happen in the velocity ki vanda two components irukum. One is the parallel component, one is the perpendicular component, and eventually what will happen? Now force or expression vanda it is same. Okay, force or expression vanda Q into VB sin theta da. Ana vanda the motion which will be very good, Tanu, very good. It will be helical. Why? Yena vandu we know that in the parallel component of velocity nala, and the charge will move forward, and in the perpendicular component nala, the charge should go circular motion as well. Combined as சொல்லும்போது, it should move in a forward direction, it should go for circular motion. So definitely this is going to be a helical shape. Understood? Now give me again a green forest in the chat box if you understood the basic idea of different different direction la nama vandu project பண்ணும்போது how it changes. If you understood, now give me a green heart in the chat box. So now in the case la uniform circular motion வரும்போது definitely on the circular motion there will be a radius, right? So now we have to find the expression for the radius, and the radius or expression da mv by qb. Mass into velocity. What is mass into velocity? Nama momentum da. So momentum by qb it will come. So momentum expression in terms of kinetic energy we know that is nothing but root of 2mk da, and kinetic energy will be equal to potential energy. Potential energy or expression we studied in the previous chapter, which is nothing but q into the potential. So I'll be getting root of 2mqv divided by qb for the radius of the circular path. இப்போ நீங்க பாத்தேனா this is for if I am projecting perpendicular to the field. Okay, இப்போ field இங்க இருக்கு, I am projecting it like this. அப்படினா மட்டும் தான் இந்த equation. Correct? Now I am going for the time period. Time period na enna? The time taken for this charge to complete one circular motion. Correct ada? Yes or no? இப்போ என்கிட்ட ஒரு charge இருக்கு. இந்த charge is going in a circular path. Okay, the charge is going in a circular path. So இந்த ஒரு charge started from here. இந்த point ல இருந்து again it should come to this position. அப்படினா what is going to be the time period taken? So இதுக்காக we know that equation time na it is distance by speed da. So distance inga பாத்தேனா definitely it will be starting and completing a circular path. அப்படினா distance, what is going to be the distance? Can you give me the answer? What is going to be the distance? அது அந்த circle, I mean அந்த circle ஓட circumference தானா? So I could say that the circumference 2 pi r divided by velocity it will come. Okay, so நம்ம time period 2 pi r divided by v it will come. Understood ada? So இப்போ in the t if you are substituting na, okay, in the v you know that we will be getting from what is in the expression la irundhu you can just find the equation for v. Adukapra you will be substituting over here and r will be get cancelled and you are going to get what? 2 pi m divided by qb. Till this understood? Can you give me a white heart everybody? Very good guys, very good Sri Varshini, very good Tanu, very good Manju. Yes Divya, very good. So we will be get it as 2 pi m divided by qb. Next நம்ம angular frequency da. Angular frequency சொல்லும்போது it is nothing but omega which is equal to 2 pi f da. F na 1 by t da. Already நீங்க இங்க இருந்து t you have found it, so you can just substitute it from here. Everybody understood? Please let me know. Yes. Actually நம்ம chat is getting very late. Okay, எனக்கு அந்த green forest எல்லாமே கிடைச்சது கொஞ்சம் டைமுக்கு அப்புறம் தான். Then I got disappointed. Hey, why you people are not giving green forest? Okay, so let me just refresh one more time. Maybe it will be sorted. Now only that white heart is coming. Oh my god, too late. Yes, perfect. So perfect. Yes. So இதுதான் the major equations that we used to study. Next இப்போ charge இல்ல, எனக்கு இருக்கிறது ஒரு current element தான். Okay, எனக்கு current carrying conductor தான் இருக்கு. அப்படினா wherever you kept this q, okay, wherever you kept this q, அங்க பார்த்தேனா what was the general expression for force? Q into v cross b தானா? Okay, v cross b தானா? So right now what I'm going to do? I know that நம்ம charge na enna? Current by time தானா? So I'll be just multiplied, not current by time, current into time dana. So I'll be just substitute over here. Now tell me velocity into time, what is that? Velocity into time, what is that? Joshua, we cannot just stick with, I mean I have given the general equation, which means if we are making it with an angle, as well as it can be in the case of perpendicular to. So that is why I have given that equation. In the case of perpendicular na, that whatever you have said you can just go for it. Very good Sri Varshini, it will be displacement, which means the length of the what? Nama current carrying conductor da. So appadina you can just replace this equation. V into t will become displacement na in the charge or a displacement the length of the conductor da. So length of the conductor into the field it will come. Okay va? Everybody understood? Give me a yellow heart if you understood. Guys, smash the like button. Why do people are becoming so selfish? If no students on the session is watching and you people cannot even give the like, it's too bad. Okay, so next on the magnetic field, nama Biot Savart law da. Idu nama what is it, நம்ம electrostatics la நம்ம coulomb's law மாதிரி. Okay, coulomb's law என்ன, we will be go for k, which means 1 by 4 pi epsilon naught. ஆனா வந்து இங்க வந்து பாக்கும்போது we will replace it with mu 0 by 4 pi. What is the value of mu 0 by 4 pi? Can you give me in the chat box? What is the value of mu 0 by 4 pi? Mu 0 by 4 pi na, yes, 7 more likes guys, 7 more likes. Okay, so mu 0 by 4 pi na, it is nothing but the 10 to the power minus 7 da adoda value varada, and this is how we will be replacing it. And anga vandu charge da nama vandu consider pannom, inga vandu we will be take the current element, which means instead of charge we will go for the current element ideal, and again nama denominator vandu same da r square. So we will be getting mu 0 by 4 pi I into dl sin theta divided by r square. Very good, very good, very good. I have told you na nama chat ellame vandu konjam slow ah da vara. So right now only 10 to the power minus 7 reached me. Okay, so now let us go for finding some of the magnetic field. In the equations ellame vandu neenga vandu you have to study, there is no other option. Okay, so nama Biot-Savart law use panni we have to study for the magnetic field for different cases. First vandu finite wire na indha madri da nama finite wire irukke. Okay, idoda length vandu ungalku theriyum, and right now you wanted to find the field at this point. Okay, magnetic field at this point. So definitely exactly similar to nama electrostatics. First thing you will be drawing a perpendicular to the point. Adikapra what you will do? You will just draw the lines to the extremes. So you will be getting two angles. Let us say theta 1. So here it is given as phi. So anyway, whatever be the angle, phi 1, and here it will be phi 2. So you will be getting mu 0 I divided by 4 pi r into sin phi 1 plus sin phi 2. இப்போ வந்து நம்ம electrostatics ல என்ன kq by k lambda by r square. Okay, correct ah, k lambda by r square into no k lambda divided by r into sin theta 1 plus sin theta 2 it will come. Okay, 5 more likes guys. So next vandu idu vandu if it is infinite na nama theta 1 illana phi 1 and phi 2 will become 90 degree. Okay, if it is infinite, wherever you see infinite na nama phi 1 and phi 2 will become coming as 90 degree. Okay, so you will be getting mu 0 by 2 pi r it will come. Next on the center, nama circular loop da. Okay, nama circular loop da. And the circular loop order magnetic field at the center it will be coming as mu 0 I by 2 r. If there are more turns, more circular turns were there, then you have to multiply it with n. Okay, vada purinjudha everybody. So next one vandu nama circular arc da, which will be nothing but mu 0 I divided by 4 pi r into theta. Theta na nama circular arc idla vandu alpha da mention பண்ணிருக்கேன். So this is what alpha. Okay vada. So next one is nothing but nama what to say, inga vandu oru circular ring irukke. So idukulla the axis la oru point da p. So definitely in the circular arc la irukra current oda flow nala what is going to be the field at this point? That is what written over here, mu 0 n I r square divided by 2 into r square plus x square all to the power 3 by 2. So try to understand, this is the value x. Okay, in the ring order radius the capital R. Okay, and the center axis il irundha nama point p varaikku irukra perpendicular distance da nama x value, and also nama capital R da vandu nama radius of the circular arc. If you understood, can you give me a green heart again? Everybody give me a green heart. All the equations you guys have to study, there is no excuse for anyone. Yena vandu we can expect any questions from any of this. We have to study. 4 more likes guys. Don't make me angry. I want more likes. Yes, perfect. So now we are going for the next set of part, which is nothing but nama Ampere circuital law. What is Ampere circuital law? Before showing that, you just tell me. From your memory you can tell me. What is Ampere circuital law? Tell me what is Ampere circuital law. Everybody tell me what is Ampere circuital law. Ampere circuital law na, it is nothing but what is it, nama current in an Amperian loop. Okay, closed integral சொல்லும்போது closed line integral. Okay, line integral BDL, which means nama what to say magnetic field into the small length, which will be equal to mu 0 times the current enclosed. Then I could say this is what the Ampere circuit law. And idu vandu use panni we can find the magnetic field inside a what is a long solenoid which will be coming as mu 0 n by I. Sorry, mu 0 n into I. So appadina what is n? N na actually vandu per unit length la what is the number of turns in per unit length. This is what the small n. You can also rewrite this with the capital N, which means mu 0 into capital N by L into I. Capital N na number of turns da, capital L na length of the what this thing da. So definitely we will be getting the due to solenoid nama magnetic field vandu mu 0 n into I divided by capital L it will come. So right now another thing is like, okay, very good Manju, very good Divya, very good Joshua, very good. So right now we should go for the another thing. Using this Ampere circuit law only, we will be going for எனக்கு வந்து two current carrying conductors இருக்கு. அதுல வந்து current is also flowing. அப்படினா definitely it will be experiencing a force each other, right? In the current is flowing in this one. Okay, it will experience it will exert a force on this one. Exactly the similar way in the second conductor இருக்கிற current நால due to this first one will also experience a force. And what is going to be the answer for it? What is going to be the force per unit length? It will be mu 0 I1 I2 divided by 2 pi d, which means இப்போ வந்து நம்ம current is flowing like this. இதோட distance of separation வந்து d தான். அப்படினா the force experienced by each of the conductor per unit length will be mu 0, the current flowing in the first one, the current flowing in the second one, divided by 2 pi d the actual வந்து நம்ம answer. இப்போ வந்து both are moving in the same direction, current is flowing in the same direction. Now I could say that this will be having an attractive force. If it is, okay, if the current is flowing in the opposite direction, now I could say that there will be a repulsive force between this. Understood? Now again, give me a red heart quickly. Give me a red heart quickly if you understood this. The force per unit length or expression வந்து புரிஞ்சிடுச்சுனா give me a red heart quickly. இதுக்கப்புறம் we are going for the torque. Okay, so guys, let me know quicker. Very good Jia, very good Sri Varshini, thank you Divya, thank you Sri Mukhi. Yes, so now we are going for the, oh my god Ankita. Okay, so now we are going for the torque. So exactly like how we have studied electrostatics and the madrida here also we are going to discuss. So nama torque oda value, what was in electrostatics? Electrostatics la dipole moment into E da. அப்படினா இங்க வந்து பார்த்தேனா magnetic dipole cross B da. Okay, so அங்க வந்து P cross E, இங்க வந்து பார்த்தேனா M cross B. அங்க வந்து what was dipole moment? Can you give me the equation? Proper equation. What was the dipole moment in electrostatic? Proper equation எனக்கு வந்து தெரியணும். What was that? The charge into the distance between the two charges. Distance of separation between the two charges. Correct ஆடா? அப்படினா இங்க வந்து பார்த்தேனா நம்ம magnetic dipole moment will be coming as the pole strength. Pole strength னா இப்போ வந்து bar magnet இருக்கு. இப்போ வந்து north pole னா I will call it as plus n. இப்போ வந்து இங்க வந்து south pole னா I will say it as minus m. So இந்த மாதிரி தான் dipole form பண்ணும். Here we will be getting plus m, here we will be getting minus m. So அப்படினா very good Joshua, very good Sri Varshini. Yes, so we will be getting what? So in the pole strength into distance of separation, which means the length of the bar magnet. ஆனா வந்து if it is coming as a circular, okay, circular current carrying conductor na அதோட expression dipole moment will be coming as I into A it will come, which means the current into area. If there are more number of turns, na, it will be coming as N into I into A. புரிஞ்சுதாடா? Everybody got it? So, அந்த நம்ம electrostatics how we have defined the dipole moment, அந்த மாதிரி தான் இங்க இருக்கும். அங்க வந்து charge-னா இங்க வந்து pole strength தான். அங்க வந்து distance of separation between the charges. இங்க வந்து the distance between the two poles இல்லனா the length of the bar magnet. இப்போ வந்து bar magnet மாதிரி இல்ல, we have a circular ring na. Okay, circular current carrying conductor na. Definitely magnetic moment we will say in terms of current and area. I into A it will come. So area வந்து we can just write. இப்போ வந்து circular na we can say pi r square. இப்போ வந்து square na we can go for A square. Okay வா? So next வந்து we understood about the dipole moment and everything. Next we have studied nama potential energy expression in electrostatics. What was that? Torque vanda, as you said, it is P cross E da. Now do you guys remember the potential energy expression? What was the potential energy expression? It is nothing but minus P dot E. Okay, minus P dot E da nama potential order expression. Appadina, here we have mentioned nama torque order expression in magnetism, it is coming as M cross B. Appadina, tell me now, what is going to be the potential energy? Can you just compare and can you please let me know the equation? Definitely what is going to be that? Minus M dot B it will come. Okay, va? And work done order expression, do you remember the work done order equation? It is nothing but PE cos theta 1 minus cos theta 2. Appadina, tell me now, what will be the expression for work done here? It will become MB into cos theta 1 minus cos theta 2. Just we are just replacing P and E with M and B. Understood? Give me a green heart quickly. Very good, guys. Very good. Sri Varshini and Sumiksha. No, sorry, Sushmita. Right? Sushmita. Yes, Divya and Manju. Very good. So this is what the expression for the work done. Okay, Vada. Everybody understood. Next one, we are going to find the magnetic moment for a revolving electron. So, ipa neenga vandu paathena, nama electron is actually moving in a circular orbit, right? So, definitely inga vandu charge flow da. Correct? Inga vandu charge flow da. So, electron is revolving in a circular path, which means it is also forming a current carrying conductor. Correct? So, eventually that orbit will become a current carrying conductor. அப்படினா அந்த கேஸ்ல இருக்கிற magnetic moment ஓட expression. So why ma'am இங்க வந்து magnetic moment ஓட expression we said it is m, ஆனா வந்து இங்க வரும்போது mu. What is the difference? Actually வந்து சொல்லும்போது we should say when we are talking about this m இல்லடா, m வந்து it is macroscopic. Okay, microscopic, which means when it comes to electron or something, we will represent mu. The only difference is this is macroscopic and this is coming as microscopic. Understood? Everybody give me a red heart if you understood. So the only difference, both are magnetic moments. Ana vanda, this is, we are talking about the electron, which is microscopic. Adanala we are just replacing, and the denotation vanda, and the representation vanda, we are just making a very small change. And the value vanda, it will be coming as EVR by 2. Okay, what is the value? EVR by 2. E na nama electron da, V na velocity da, R na nama radius of that orbit da. Next one, we should study a ratio, gyromagnetic ratio. Very simple. If we have studied nama magnetic moment for an electron, okay, microscopic da, other divided by nama angular momentum pannumbodhu, we will be getting a constant on the right hand side. Okay, va? So in the magnetic moment per angular momentum will give you a constant on the right hand side, which will be coming as E divided by 2 into ME. E na constant da, nama charge of electron da, 2 வந்து again a constant value da, m in a mass of electron da, இது வந்து change ஆகாது. So அப்படினா I could say that நம்ம gyromagnetic ratio will be a constant value. Okay, அதோட value வந்து it is given 8.8 into 10 to the power 10 da actually வந்து அதோட value வருது. Till this understood everybody? Yes or no? Please give me Y or N everybody. In the each and every terms வந்து important da. அதனால தான் I'm just asking again and again. Everybody should respond. Okay? So the only difference is this is macroscopic and this is microscopic, and I'm taking, okay, in the value mu well I got it, divided by angular momentum da எனக்கு வந்து ஒரு constant value கிடைக்க போகுது. Next வந்து எனக்கு வந்து இந்த constant value which I got it, no, அது வந்து I wanted to get it for minimum. Okay, I wanted to get it for minimum. That is what Bohr magneton. Okay va? So நம்ம Bohr magneton நம்ம ground state ல இருக்கிற electron ஓட n is equal to 1 வரும்போது what is the magnetic moment. That is what the Bohr magneton, which will be represented as mu b. Adoda value வந்து constant da, again n is equal to 1 we will put. So it will be coming as 9.27 into 10 to the power minus 24. இதுல வந்து நம்ம angular momentum பார்த்தேனா we will be get to know நம்ம according to Bohr. What was the angular momentum? Do you guys remember? நம்ம atom chapter la we are studying the postulates of Bohr. So அதுல வந்து we are studying no L is equal to NH by 2 pi da. So அந்த L க்கு வந்து we will be okay in the equation la L க்கு வந்து we will give the representation and இதுல வந்து N க்கு we are going to give as 1. So அந்த ஒரு டைம்ல we will be getting the minimum magnetic moment for this electron at the ground state, and that is what very good Srimukhi, Srivarshini, very good. So this is what the target achieved. Very good, very good, very good, very good, super, super, super. Okay, so this is what our Bohr magneton. Now we are going for the another concept which is nothing but nama galvanometer. Ready na? Give me some fire, everybody. If you are ready for galvanometer, give me some fire. Everybody. Perfect. Okay, so now. இங்க வந்து நீங்க பார்த்தேனா நம்ம galvanometer ஓட principle enna. What is the principle? Definitely when we are placing, okay, we will be having the what to say nama coil ku vandu, okay, when we are placing a coil in an external field adula vandu it will experience a torque, and we have studied adu vandu m cross b da. Okay, lots of fires. Okay, so right now we know that when we are placing a coil in an external magnetic field, it will experience a torque. Okay, and the torque will be equal to number restoring torque. We will be connecting a spring, and definitely when the coil is rotating, there will be a restoring torque will be, then a restoring couple will be developed in the spring, and due to that we will be getting the moving coil galvanometer. Adla vandu paathena nama m cross b sollumbodhu, okay, m cross b sollumbodhu what is n into I into a into b da vandu nama value. Again sin theta will be there, but we will be using cylindrical magnets as the external magnets. Why we are going for cylindrical magnets? Ena vandu ovvoru point ilume, okay, ovvoru point ilume to get the maximum torque, which means the angle between magnetic moment and the field vandu it should be always 90 degree. Okay, it should be always 90 degree. Adukagada we are actually using the cylindrical type magnets to get the maximum torque, which will be equal to number restoring torque, which is k theta, and we will be getting the current which is equal to k by NAB into theta, which means I could say that the current will be proportional to the deflection. This is how the moving coil galvanometer works. Got it? So very simple. We will be place a coil inside the external field. So it will experience a torque, and due to that there will be restoring torque developed in the spring, and that will be equal. And if it is equal, I could make a relation like this, which means the current which is flowing in the circuit, which is proportional to the angle of deflection. Now another two terms which we should study is nothing but current sensitivity and the voltage sensitivity. Very simple. If you know this equation, just take, okay, nama theta by I, whatever is coming, that is what current sensitivity. Theta by V, that is what voltage sensitivity. So V vandu inga direct ah paaka mudiyadha, so you can just rewrite this I. Okay, I na enna, we know that V is equal to IR da. So appadina you can just replace V by R as I. So now if we are replacing V by R over here, you will be getting the voltage sensitivity as well. Understood now? Can you give me a green heart again, everybody? If you understood the moving coil galvanometer, the current sensitivity, the voltage sensitivity, please give me a green heart in the chat box. As I mentioned, I wanted to see a kind of what to say, nama green forest vandu enakku paakanum. Green forest. Yes, adukkulla some red flowers also. Manju is actually giving some red flowers also. Eppovume vandu in the green and red combination vandu it is so super, right? Ipo neenga vandu if you are going to nama what is they called Dekanal side and all, if there will be some kind of what to say what is it, that slanted areas will be there. No, anga vandu paathena there will be some kind of red flowers with a lot of green leaves we can see. No, yes, Kavilash, right? Yes, Kavilash, it's so good. Okay, so now let us go for the what else we have, nama conversion, galvanometer into ammeter and the voltmeter. So galvanometer சொல்லும்போது we know that it is a very sensitive device da. So ipo vandu and oru device vandu if you need to convert into ammeter na, you should give a very small resistance, which means shunt resistance parallel to the galvanometer. Okay, what you should do, so whenever we are talking about conversion of galvanometer into ammeter, what you should do, you should keep the shunt resistance across the or parallel to the galvanometer. Guys, don't forget to like the session. Do not forget to like the session. Okay, so on the shunt resistance oda value da nama galvanometer la pass pandra current divided by the the rest of the current into galvanometer oda resistance. If you wanted to convert this into a voltmeter na, you should give a high resistance series with the galvanometer. Okay, you should give a high resistance series to the galvanometer. Appadina nama R value, okay, nama high resistance oda value will be coming as the potential divided by Ig, which means the current passing through the galvanometer minus galvanometer oda resistance. Understood everybody? Yes or no? Give me again your favorite heart in the chat box if you understood. We have done the magnetism, moving charges and magnetism. Next one, nama second part da, nama magnetism and matter. Ready na? Ready ya? Guys, you are not giving likes. Why? What is the reason? If low students is watching, I can say hardly 20 students still they didn't even like this session. I am giving reminders, and my warriors, they are also giving the instructions, and they are giving some kind of a warning for you people, but still you people are not doing it. Wow, it is so beautiful. Now I understood few of your favorite colors. Okay, so right now we are going for the magnetism and matter. So in the chapter pathena there will be some in the chapter there are a lot of things to by heart. That was the major thing. Okay, so nama bar magnet da first one nama discuss panna poro. Bar magnet la we know that there will be north pole and south pole, and how will be the field lines. Can you give me the properties of field lines, everybody? Can you please let me know the properties of our field lines? Properties of field lines, everybody. Properties of field lines, definitely it is starting from the north pole and it will end to the south pole, outer the magnet, outside of the magnet. Inside it will be going from the, oh my god Joshua. super. Okay, inside it will be south to north. Very good Srivarshin. And it will form closed loops. Very good. And also direction, if you wanted to find the direction now, very good, inside south to north. And if you wanted to find the direction now, you should go for a tangent at that particular point, and that tangent will give you the magnetic field or a direction. On the point magnetic field or a direction will be given by that particular point tangent. And two field lines will never form two field lines will never intersect, and a two direction at the point is not possible. And very good Srimugi, tangent to a tangent of the point, closed continuous curves never intersect each other. Yes Elma, tangent to the field lines. Very good. Adukapram the bar magnet is actually like a dipole, right? Bar magnet is actually like a dipole da. So appadina definitely nama field we have to find it, right, at different positions. So ipo neenga paathena in the equation I will suggest you people at this moment study these equations. Okay, ipo nama R value is much greater than the length, or let's say the the difference between distance or separation between the poles na, you can go for this two equation. If you have studied everything, ma'am, na vandu ellame finish pannirken, so definitely I can study few more equations na, you can go for this two equations as well. I will be suggesting first go for the important equations. Idukku vandu least priority da. If you wanted, you can just study right now. If you're feeling like enakku vandu ennala mudiyum ma'am, so appadina you can just go for it. There is no issues on it. Okay. Yes, very good. So now tell me, what is the Gauss's law in electrostatics we have studied? Do you remember that? We have just now only we have studied, right? Gauss's law in electrostatics. So now tell me, what was that? What you have studied? Electrostatics illa nama Gauss's law. What was that? What was that? What was that? It is nothing but the flux which is equal to the electric flux which is equal to the 1 by epsilon naught times the charge enclosed. Correct? Namma electric flux which is equal to the charge enclosed divided by epsilon naught. Now tell me what is going to be the Gauss's law in magnetism. Can you please let me know? Can you please let me know what is going to be the Gauss's law in magnetism? Everybody. Please let me know. Very simple. Idu vandu eppovume closed loop form pannumla. So we can say that the magnetic flux, okay, in a closed surface will be coming as 0. Yena vandu in the field lines will always form closed loops. Okay, it will always form the closed loops. Understood everybody? So Gauss's law in magnetism varumbodhu it is nothing but very good Elma, very good Jehi, very good Srivarshini, very good Jokshwa, very good. It will be coming as the net magnetic flux in a closed surface will be always 0. What is the reason? Yena vandu nama field lines will always form the closed loops. Got it everybody? So now can we go for the next part? Nama, we are going for some of the important terms. Magnetization na nama magnetic moment per unit volume da. Next one the magnetizing field. Magnetizing field sollumbodhu it is nothing but B naught divided by mu naught. Okay, B naught na enna? Ipo vandu nama solenoid paathena it will be coming as mu 0 Ni. Okay, nama magnetic field mu 0 Ni divided by mu 0 it will come for the case of solenoid. So we know that mu 0 will be get cancelled, and what is going to be the magnetizing field you will be getting? You will be get it as Ni. Purinjidada? So next one vandu the total magnetic field inside a material. Inside a material sollumbodhu of course B naught irukum plus and the material nale. Okay, and the material nale irukum. So we can say that this will be nothing but mu 0 into H plus M. H na magnetizing field da, M na nama magnetization da. Okay, va? So this is what the another expression. Next on the magnetic susceptibility. It is nothing but if I am introducing a material in an external magnetic field, how effectively or how easily it will be get magnetized. Okay, so right now what we were discussing? We were discussing about the magnetic susceptibility, which means if I am placing a magnet, okay, or let's say material, how easily this material get magnetized. That will be mentioned by this magnetic susceptibility. This is very important, and I'm going to show you some more equations relating with this. All are very important. So exactly in a similar way, we discussed the same equations in electrostatics. At that, on the last 1 minute we have discussed some of the relative permittivity and the electric susceptibility or relation. And the madri inga kuda irukku, nama relative permeability will be equal to 1 plus magnetic susceptibility. Also you can go for mu will be equal to mu naught into mu r. Mu r na enna? What is the relative permeability da? So which will be coming like this. Understood everybody? All these equations were very important. You have to study all these equations. All the equations are very important. And the equations vattum you have to study. In the chapter irukra questions ellame vandu you can just study. Okay? So next vandu paathena nama magnetic flux da. So magnetic flux sollumbodhu what is magnetic flux? What is magnetic flux? We know that இது வந்து magnetic field lines தான். நம்ம வந்து electric flux சொன்னல. So அந்த மாதிரி இது கூட actually வந்து magnetic field lines தான். which will pass as perpendicular to the surface. Which will pass perpendicular to the surface. Now, I will call it as magnetic flux. Only one condition, the magnetic field lines should pass perpendicular to the surface. Are you guys here? Yes or no? Give me a heart. Give me a favorite heart. Because I can't see you people for a long time. Where are you people? Let me know, let me know. இவ்ளோ பேர் இருக்கே ஆனா வந்து ஃபீலே ஆகல. So in the chat வந்து லேட் ஆகுதுனால it is again coming as yes Amiksha, yes Angeline, yes Srivarshini, okay, you people are there, okay, fine, now sorted. Okay, so nama magnetic flux வந்து it will be coming as like the same way nama electric flux oda expression enna, it is E dot A. So அந்த மாதிரி இங்க வந்து பார்த்தேனா field into A, so magnetic field into A it will come, so BA cos theta it will come. If it is a varying field na, you should இது வந்து constant field na மட்டும் தான் இந்த equation you can use it. If it is a varying field na, you should go for this equation for the flux. Understood everybody? So nama flux dot expression என்னடா? You are new, welcome to Re-NEET Tamil Nadu. Okay, so this is what the magnetic flux. Now another thing is like we have to go for the Faraday's law. What is Faraday's law? What is Faraday's law? So definitely we know that if there is a change in flux, okay, if there is a change in flux, it will induce the EMF. புரிஞ்சுதாடா? If there is a change in flux na, it will induce the or let's say it will induce the EMF. அப்படினா I could say that okay, it can induce the EMF, and the induced EMF oda value வந்து it will be d phi by dt. Okay, d phi by dt. So Faraday's law la actually வந்து he could only explain about the magnitude. Lenz's law la da actually வந்து induced EMF will be always opposite to the, okay, always opposite to the change in flux. So definitely induced EMF will be coming as minus d phi by dt. Understood? Now give me a fire if you understood everybody. So இப்போ வந்து பார்த்தேனா நம்ம fluxல change இருந்துச்சுனா, okay, fluxல change இருந்துச்சுனா definitely there will be an induced EMF, and the induced EMF oda value வந்து minus d phi by dt da. So minus what is the purpose of that minus sign? What is that minus sign? எப்பவுமே the induced EMF and the flux will be always in the opposite direction. Always in the opposite direction. So now இப்போ வந்து இந்த coilல n number of turns இருந்துச்சுனா whatever we have studied அதுல வந்து we will be just multiply with the number of turns. Okay va? Number of turns வந்து we will multiply. Next வந்து induced EMF இருந்துச்சுனா definitely அங்க வந்து induced current இருக்கு, கரெக்ட்டா? And the induced current ஓட expression என்ன? Induced EMF divided by R. ஏனா வந்து we know that I is equal to V by R தான். இங்க வந்து induced EMF we will replace and we will be getting N by R into d phi by dt. Okay vada, it is nothing but d phi by dt. Next வந்து எனக்கு what I need is like induced charge தான் எனக்கு வேணும். Induced current வந்து எனக்கு புரிஞ்சிடுச்சு. Now I want the induced charge. What is the charge or equation? I into delta theta, delta t the delta q. அப்படினா I oda expression வந்து we already got it. So now multiply it with delta t. So you will be getting n by r into delta phi. Understood? Please everybody give me a heart, everybody. If you understood till this, give me a heart, everybody. So this is what the induced EMF, induced current and the induced charge. Okay. So now we are going for the motional EMF. Okay, we are going for the motional EMF. So definitely we know that what is motional EMF? What is motional EMF? Definitely when the, if I have a rod, okay, this is moving. So idukulla irukra charges kuda it is also moving. So on the charges oda movement inala definitely there will be a potential difference created. That is what nama induced EMF. And the induced EMF is due to the motion of this particle. So adinala I will be getting the expression as B into V into N. B in a magnetic field, V in a velocity, and L in a actually வந்து நம்ம length of the conductor. Okay va? Length of the conductor. So that is what the thing. So in the EMF will be coming as, okay, EMF will be coming as the BLV. Next வந்து இந்த BLV இருக்கு. Now the force moving on this conductor, okay, force on the moving conductor, which will be coming as ILB. We already studied in the magnetism chapter, correct? We have already studied the chapter, magnetism chapter we studied I into L cross B. This is the maximum, so I'll be getting ILB, and our expression I will be getting it as B square L square V divided by R. Okay, in the I term in the current I will be replace it as, okay, F is equal to ILB da, and I will be replace it as EMF, the induced EMF divided by R into L into B. In the EMF value the BLV da, so that I will be substitute and I will be getting this expression. This ma'am by heart pannanuma? No, you don't have to by heart this. You can just study this equation. Idhula just a substitution mattum da thevaiya irukku. Okay, wow. So next the power da, okay, mechanical power required, and that will be coming as force into velocity. We have studied this equation in the class 11th grade. So power or equation and force into velocity. Force you already got it from here. Into V pannumbodhu, into velocity pannumbodhu, you will be getting the power order value. Understood everybody? Please let me know in the chat box. Everybody please let me know. Everybody, yes or no, by or n? Everybody. Okay. So now we are going for the next set, which is nothing but, let us say we have discussed in the road move achna, what is the induced EMF and all we have discussed. Now I have a road and that is rotating. Okay, in the rotation nala kuda I will be getting the magnetic field. Okay, due to this rotation also I will be getting the magnetic field. I will be getting the induced EMF, and the induced EMF for expression the half into B omega L square. What is omega? It is nothing but, now it is what is nama rotation dana. So rotation varumbodhu we will be replaced it as what? Nama angular velocity. So I will be getting half into B into omega L square. So if on the omega na, it is actually 2 pi f da. So if you want it, you can just substitute 2 pi f and you will be getting this equation. B into angular frequency into pi into L square. Got it? So next one, instead of this right now a disc is rotating, a metal disc is rotating. Appadina kuda we will be getting the induced EMF, which will be half into B omega into R square. So in the vati R na, it is actually the radius of the disc da. Okay, radius of the disc da in the R oda value. So along with whatever you have studied about this EMF, you should study this as well. Okay, so now we are going for the major part of this chapter, which is nothing but nama self and the mutual inductance. Okay, self and the mutual inductance da nama discuss panna porom. So self inductance na enna? It is actually ipo enkitta oru current carrying conductor irukku. So I'm just changing the current order, what is the magnitude, I'm just going to change. Okay, I'm making some changes. So on the flow of current change agumbodhu, on the same current carrying conductor there will be an induced EMF formed. Okay, so if there will be a current carrying. Okay, illana we have the what is a current carrying conductor, the current is flowing. If I'm just changing the current order value, so definitely I'm going to flux change irukum. Flux change irundhuchna what will happen? Induced EMF will be formed. Correct? Yes or no? Are you guys getting it? If you're getting it, please give me a heart in the chat box. Everybody, quick. So what I'm saying, so ipo in the charge is actually yes guys, smash the like button guys, smash the like button. Why you guys are not doing it? I don't understand. Okay, so now what we were discussing, in the same current carrying coil due to the flow of current there will be some sort of change will happen. So in the flux change there will be some induced EMF will be formed in the same current carrying coil, which this phenomena is known as the self-induction. And in the self-induction we can say that nama self-inductance L oda value it is nothing but nama phi divided by current da. In the expression is very important. Nama flux is proportional to the current irukum, and the proportionality change pandradhukku use pandra oru what to say nama what is constant da நம்ம L value. Right now to get the induced EMF, now what we should do, we should differentiate this. ஏனா வந்து induced EMF na enna minus d phi by dt da, so I'll be going for minus d by dt of Li. Okay, ஏனா phi வந்து Li, L na I have already told you அது வந்து constant da, so minus L di by dt, it will come as the induced EMF in the self inductance. புரிஞ்சுதாடா everybody? Please let me know. So இப்போ வந்து you have to study especially for the solenoid in this case. So when it comes to solenoid, okay, when it comes to a solenoid, nama self inductance oda value வந்து you have to study da, you have to study mu 0 n square a divided by L. N-na we know number of turns da. If you wanted to replace, we know that small n na capital N divided by L da. So if you wanted to replace in terms of small n, you can just replace it as n into L divided by what to say a vandu, you can just replace. Purinjudada? Everybody understood? Everybody understood? Then L is equal to current sensitivity. How da? How? அது வந்து theta by I da. இது வந்து flux da. அது வந்து angle of deflection. Got it? புரிஞ்சுதாடா? Divya? Yes. So now we are going for the mutual inductance. So tell me now what must be the mutual inductance? இப்போ வந்து current is flowing in one coil and we know that நம்ம induced EMF also generated in the same coil. But when it comes to mutual induction, okay, when it comes to mutual induction, what will happen basically? Yes, the current is flowing in one circuit. Okay, current is flowing in one circuit, and the current flow nala flux change is happening in some other one, which means induced EMF is produced in the other coil, which means mutual da. Okay, so you will, I mean, exam ku vandu nama means whatever say we while we are studying, while we are writing, no, on the time we will do some kind of mutual understanding, right? And the madri da. Okay, so effort vandu inge irukke, result vandu inge irukke. So which means in the oru coil la current is current is flowing, magnetic field is produced, adanal irukra flux change and induced EMF will be produced in the other. So this is what mutual induction. And in the mutual induction lab, we can see that phi 2, which means the flux changing in the second coil. What is the reason for it? Nama first coil la pass pandra current da. Correct? Okay. Actually, the flux is changing in the second coil. What is the reason? Yena vandu nama first coil la current is flowing. Angada vandu magnetic field produce aayirukku. So I could say that phi 2 will be equal to M into I1. Okay. M na nama mutual inductance da. அப்படினா I'm just going for the d phi by dt. ஏனா எனக்கு வந்து induced EMF புரியணும்ல. So which will be coming as minus M into di1 by d2. What is this? The induced EMF in the second coil. Okay, induced EMF in the second coil will be equal to minus M di1, the current, the change of current with respect to time happening in the first coil. And right now, if you have two coaxial solenoids, which means axis vandu both the solenoids oda axis vandu same da. And oru point if you need to find the mutual inductance na, which will be coming as mu 0 n1 n2 a divided by L da. Purinjudada everybody? Are you guys getting what I'm saying? Yes or no? Please give me a red heart if you understood. Everybody give me a red heart quick. Everybody please quick. Yes, perfect. So appadina right now we are going for the coefficient of coupling. Coefficient of coupling na I have told you now. So ipo in the solenoid can be like this. Okay, idudha vandu nama first solenoid. Another solenoid is like this. Okay, another solenoid is like this. So inga vandu paathena idu vandu coaxial da, which means in the two solenoids oda axis vandu same da. So definitely we will be getting the maximum value for it. Okay, we will be getting the maximum value. And one coil is here, another coil is here. So definitely nama coefficient of coupling kuda it is going to be reduced. So definitely we won't be getting, okay, in the coaxial argumodu whatever be the induced EMF we got it, adha vida kammi da if it is coming like this. And the coefficient of coupling of we can just find it as m divided by root of L1 L2. In the case la nama k value will be coming as what? Ena vandu coaxial irukku. Okay va? So it will be coming as m, which is equal to root of L1 into L2. Understood, guys? Everybody, please let me know. Everybody. So right now we are going for the energy stored in the inductor, which will be coming as half into Li square, and also energy density சொல்லும்போது this energy divided by unit volume da, which will be coming as B square by 2 mu naught it will come. So energy stored in the inductor is also important da. So next one, the combination of inductors da. Okay, combination of inductors da. If the inductors are in series, okay, if I am connecting the inductors are in series, okay, so this is how it is. Appadina what will happen? This is L1, this is L2. Appadina L equivalent will be coming as L1 plus L2. It will be exactly like how we have discussed about the resistors. Okay, so now tell me if I am connecting the inductors like this. Okay, inductors like this, which means parallel. Appadina what is the effective inductance, what is going to be that? This is L1, this is L2. So obviously it will be L1, L2 divided by L1 plus L2, it will come. So these are the things we should study in the chapter of electromagnetic induction. Till this understood, everybody? Till this understood? Give me a green heart, everybody. Give me a green heart. Quickly give me a green heart. Everybody. So now we have AC generator also. AC generator is works under the principle of electromagnetic induction da. Okay, electromagnetic induction da. And also we know that phi will be coming as NB cos omega t da. And induced EMF now we will just differentiate this. So what we will be getting as induced EMF? Minus NBA. We will differentiate cos omega t. So that will be coming as omega into sin omega t. And this is going to be the maximum value. Okay, we will say the maximum value of E max value, the peak value will be coming as NAB omega. So you should study this as well. Got it? Yes or no? Yes or no? So this is what we need to study in the AC generator. The principle is very important, and induced EMF for the expression is also very important. So now let us do one thing da. We can again go for a very kutty small break. We can just continue. Okay, so we will be resumed. At what time you can come? Please let me know. Resume time, please let me know. Okay, 7:15. Okay, so let us just come by 7:15. So take a proper break and just you have to come back also. If you are not coming back, I won't take the rest of the chapters. Okay, done? Promise, pinky promise. Okay, so see you guys. We will meet. Okay, yeah, by 7:20. Fine. Okay, 7:15, 20 in between you can come. So by 7:15 I will come. I will show my attendance. Okay, I'll mark my attendance. So you guys have also should come back. Okay, so see you guys. Hello everybody. Where are you people? I can't see you people here. Where are you? Let us start with AC. AC, ready? Ya? Ready now? Put some fire on the chat box. Yes, Jay. Yes, Veda. Hi, 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 hi. Yes, Srivarshini. Yes, Angeline. Yes, Ankita. Irukkum, ma'am. Okay. So now we are going for the AC chapter. So in the alternating current first one we should understand. Let us say if we are just considering a complete cycle. Okay, if we are considering a complete cycle now, our average value என்னதான் வரப்போறோம்? If we are just considering the complete cycle, it will be coming as 0. So definitely we cannot consider that. So adanalatha we are introducing a value which is nothing but apart from this average value, wherever the arithmetic operation comes to be 0, at the moment we will introduce another quantity which is nothing but nama RMS value. Okay, RMS value. So RMS value na root mean square value. So அப்படினா first we will be going for the root mean square value. So இது வந்து nothing but நம்ம IRMS value. Okay, IRMS value which will be coming as, can you please let me know in the chat box what is the value? It will be coming as I0 by root 2. Am I right or wrong? Am I right or wrong? In the madri you can just tell me what is VRMS. What is going to be VRMS? What is going to be VRMS? It will be nothing but V0 divided by root 2. So this is what the first thing we should understand. Now let us go for this AC circuit with the pure elements, which means first you will be connecting AC with resistor only. Okay, we will be connecting resistor only. So on the time what you will get to know, we will get to know the voltage and current vanda, it will be in phase, which means there is no phase difference between the current and the voltage. Okay, so இப்போ வந்து நீங்க வந்து பார்த்தேனா நம்ம current oda expression வந்து it will be coming as I0 sin omega t, and நம்ம voltage oda illa நம்ம EMF oda value வந்து it will be coming as V0 sin omega t, and the peak value வந்து I0 da, adoda value வந்து it will be coming as V0 by R. This is what happening in the pure resistor. Now it comes to inductor. Inductor la pathena nama voltage leads the current by pi by 2. Okay, so nama resistor la this is what we are. So nama current is also coming like this. Okay va? Ana on inductor circuit la what will happen? The voltage leads. Okay, so voltage வந்து இப்படி தான் இருக்க போறோம், and current will be like this. Okay, voltage leads current by pi by 2, which means அந்த கேஸ்ல இருக்கிற நம்ம phase difference வந்து it will be pi by 2 தான். So அப்படினா I should tell you what will be the expression for V. If I am taking the voltage as V0 sin omega t, nama current oda value vanda, there is a pi by 2 phase difference illada. So current oda value vanda I0 sin omega t minus pi by 2. Okay, nama next target ku 25 likes more. Okay, everybody don't forget to like. So this will be coming as in the pi by 2 is only because there is a lag. Current is lags behind the voltage. So that is why this pi by 2. So இப்போ வந்து பாத்தீங்கன்னா நான் வந்து we are discussing resistance here. அந்த மாதிரி இந்த இண்டக்டர்ல இருக்கிறது தான் inductive resistance. Inductive resistance we will represent it as XL. Okay, inductive resistance வந்து it is nothing but what? நம்ம XL தான். So actually வந்து சொல்லும்போது inductive reactance, and இதுக்கப்புறம் we will study capacitance reactance. So now what is the difference with the resistance? Can you please let me know? Can you please highlight what is the major difference? What is the major difference? Can you just give me an idea about it? So இப்போ வந்து நமக்கு வந்து reactance இருக்கு, resistance இருக்கு, inductive reactance இல்ல capacitive reactance எல்லாமே இருக்கு, and resistance is there. What is the major difference? Major difference சொல்லும்போது இந்த resistance ல there will be a energy loss இருக்கும், okay, in the form of heat. ஆனா வந்து நம்ம inductive reactance இல்லனா capacitive reactance, there is no power loss, or let's say there is no loss in the form of heat. That is what the major difference. and our inductive reactance oda expression vandu omega into L da. Omega na enna 2 pi f da. Okay, 2 pi into frequency da. So 2 pi f into L. L na inductance da. This is what nama XL. Ipo vandu I'm just asking you what is the peak value? Okay, what is the peak current? Can you give me the expression for peak current? What is the expression for peak current? What will be that? What will be that? The peak voltage divided by number reactance. So it will be coming as V naught, or let's say the maximum, the peak voltage divided by XL. So we will be getting it as, if we are replacing it, we will be getting V naught divided by L omega. Understood? Now can you give me a red heart quickly, everybody? So right now we are going for the capacitance. Okay, we are going for the capacitance. We are connecting AC into a capacitive circuit. So nama voltage, I mean the inductor la is that nama voltage leads the current. Ana vandu inga vandu reverse da. So ipo vandu nama voltage eppadina current is actually leading by an angle pi by 2. Appadina previous case la whatever we have mentioned adu vandu we will be just replace here in the phase difference vandu plus pi by 2 da. Actually vandu current is leading. So definitely voltage vandu V0 sin omega t na current will be plus pi by 2. It is actually leading. So we will be getting I0 sin omega t plus pi by 2. So next நீங்க வந்து பார்த்தேனா நம்ம capacitive reactance தான். Capacitive reactance சொல்லும்போது we will be going for XC. இதோட expression என்னன்னா 1 by omega c தான். ஓகேவா? omega na again 2 pi f தான். So you will be getting 1 by 2 pi f into c. Understood, Ada? Very good, Divya. Very good, very good. Current leads by 90 degree in the case of pure capacitor. Okay, can you please let me know what is the peak current? What is the peak current in this case? Peak current is V0 by XC da, which means V0 divided by what is XC? 1 by omega c. Okay, got it, everybody? Yes. It is already there da. எனக்கு வந்து அந்த லிங்க் வந்து பேஸ்ட் பண்ண முடியாதுல்ல, நம்ம கமெண்ட்ல பேஸ்ட் பண்ண முடியாது. ஆல்ரெடி we did a video, அதுல வந்து அந்த லிங்க் எல்லாமே வந்து டிஸ்கிரிப்ஷன் பாக்ஸ்ல இருக்குடா. ஓகே, very good. So இப்போ வந்து இந்த inductor, capacitance, resistance எல்லாமே வந்து we are going to connect in series. Okay, we are going to connect in series. So அந்த ஒரு டைம்ல what will be the what is going to be the net resistance இல்லனா net opposition to AC. அதுதான் வந்து first point பண்ணனும். So அப்படினா we know that in the impedance, okay, impedance வந்து the impedance will be there. So அப்படினா I could say that நம்ம V0 இப்படி தான் இருக்க போறோம், and here we will be having, or let's say VR, it will be like this, and here we will be having VL minus VC. இப்போ வந்து impedance triangle பார்த்தேனா what will happen? Here we will be having the resistance, and இங்க வந்து பார்த்தேனா XL minus XC, it will be there. It is depending upon the reactance value. இப்போ வந்து XL is more na, I will call it as inductive circuit. If XC is more, I will be call it as what? Capacitive circuit. If XL and XC is equal, now I will say it is a resistive circuit. Purinjadada? Everybody got it? Yes or no? Please let me know, guys. Everybody understood? Give me a green heart. So ipo vandu we were discussing about the impedance. Adukku vandu I have mentioned the impedance triangle. So impedance triangle na enna? It is nothing but resistance vandu ipdi da, and XL minus XC will be coming over there. Ena vandu we know that there is the, I mean first inductor la in the voltage is leading, and capacitance la namma current da lead pandrom. So definitely we will be get it like this. So idoda magnitude vandu we are actually representing it as two vectors. Idoda magnitude vandu in the third side da. So using Pythagoras theorem, okay, using Pythagoras theorem, what you will be getting? Root of XL minus XC the whole square plus R square, it will come. So we will be getting the impedance as root of XL minus XC the whole square plus R square, it will come. Next வந்து நம்ம current oda expression da. Current oda IRMS will be coming as VRMS divided by Z, it will come, and peak value will be coming as peak value of voltage divided by நம்ம impedance oda value. Next வந்து tan phi na actually வந்து நம்ம phase angle da. Phase angle சொல்லும்போது this is what phi. அப்படினா opposite side divided by adjacent side. What is opposite side? XL minus XC divided by adjacent side. What is adjacent side? It will be coming as R. So you will be get it like this. Exactly similar to this, you can also go for phi as this angle. This is also we can mention it as phase angle, which will be again VL minus VC. Adjacent side will be VR. So this is what the series LCR circuit. All the equations, everything is very important. I hope you guys will study everything. Next one is important thing, the resonance. Okay, what is resonance? When the reactance order values, which means inductive reactance and capacitive reactance it is coming as equal, which means I could say XL, which is equal to XC. Okay, wow. XL, which is equal to XC, I could say there will be a resonance. So resonance the first condition XL is equal to XC. So if it is XL is equal to XC, can you please let me know what is the impedance order value? If XL is equal to XC, what is going to be the impedance order value? It will be minimum, and that will be equal to very good Shrivarshini, it will be coming as R. XL minus XC. In the equation path, XL minus XC will be coming as 0 if it is equal. So root of R square it will come. So that will be simply R. Okay, so this is what the resonance. So in the resonance, we could say XL is equal to XC. XL it is nothing but omega L, which will be equal to 1 by omega C, which means XC. So we will be getting the resonant frequency, resonant angular frequency, which will be 1 by root LC. Very important, you have to study the frequency order expression, which will be omega. Omega, what is that? It is nothing but 2 pi into the frequency, the resonant frequency. So resonant frequency 1 by 2 pi into 1 by root LC it will come. Very important. And the conditions we have mentioned, what is it? Impedance minimum and current should be maximum, which will be V by R. We know that current order value V divided by Z. Okay, so Z is minimum value, so R it will come. Denominator will be minimum, so which means value it will be a larger value. And in the case when it comes to resonance, phase angle it will be nothing but 0 degree. Understood everybody? Everybody understood? Please give me a green heart if you understood. Resonant frequency illana resonance reactance same XL will be equal to XC, and the resonant frequency will be coming as 1 by 2 pi into root LC. And also the condition impedance minimum which means Z will be equal to R. Current maximum which means V by R it should come, and also phase angle should be 0. Okay, what everybody understood guys? Smash the like button guys, everybody. Okay, now we are going for the quality factor. So quality factor it is nothing but resonant frequency into L divided by R, or otherwise we can go for 1 by resonant frequency into CR. Okay, which will be equal to 1 by R into root LC, the actual value. So we can also say the quality factor resonant frequency divided by bandwidth. Okay, resonant frequency divided by bandwidth. All the equations were important. You guys have to study quality factor, which is equal to 1 by R into root LC. All equations are very important. Now we are going for the power in AC circuit. We know that power order expression, average power order expression VRMS into IRMS into cos phi. And when it comes to resistive circuit, okay, resistive circuit varumbodhu nama cos phi 0 agum. Correct? Just note it down. Nama resistive circuit la cos phi it will be cos 0 1 it will come. So adanal anga oru what is it nama power loss. Okay, that is what VRMS into IRMS. And when it comes to inductive or capacitive circuit, what will happen? Cos phi will be, phi is 90 degree, cos 90 will be 0. So adanala there won't be any power loss in the case of purely capacitive circuit and in the case of purely inductive circuit. Okay, and next one is power factor which will be coming as R by Z. Okay, cos phi will be coming as R by Z power factor, which is also So very important. Purely resistive circuit, it will be Vrms into Irms. Purely capacitive circuit, average power loss will be 0. Purely inductive circuit, it will be 0. Next one is nothing but the wattless current. The component of AC, which means nama Irms into sin phi, which will be having no power loss. There is no average power. So we will be call it as Irms into sin phi. We will be call it as what? We will be call it as wattless current. Not all the equations, all the equations were very important. Let us go for the next part. Ready now? Give me a green heart. Everybody, if you are ready for the next part, give me a green heart quickly. Everybody. Yes. So now we are going for the last part of this chapter, which is nothing but transformer. So in the transformer, it is nothing but. So sometimes it is actually working on the principle of mutual induction. Let it be there. Actually, if you need to increase the voltage, you can go for step up transformer. If you need to reduce the voltage, you can go for step down transformer. This is what actually, this is why we are using the transformer. So in the transformer, you should study this ratio. The voltage in the secondary coil divided by primary should be equal to the number of turns in the secondary divided by the primary. Current will be just ulta. Okay, current will be the primary divided by the secondary. Idellame the same. Now it is for the step up transformer. Step up transformer na nama voltage the secondary coil la adhigama irukkanum. So which means number of coils in the secondary should be very high. Understood? Are you guys getting what I'm saying? So இப்போ வந்து step up transformer actually வந்து நம்ம secondary coil நம்ம output வந்து high இருக்கணும். Step up இல்ல. So definitely number of turns in the secondary should be very high. அப்படினா we know that secondary coil தான் நம்ம potential இல்லனா நம்ம voltage வந்து high இருக்கும். அப்படினா நம்ம current ஓட relation will be coming as secondary current order flow will be less comparing to the primary. Step down சொல்லும்போது என்னடா நம்ம voltage வந்து reduce ஆக போறோம். கரெக்ட்டா? நம்ம voltage in the primary circuit will be high comparing with the secondary. அப்படினா what is going to be the relation connecting number of turns? Can you please let me know? Step down transformer number of turns in the secondary or primary, which one should be high? Can you please let me know? Secondary na give me S and primary na give me P. Step down transformer we need to get less amount of voltage. Appadina number of turns less. It should be less in the case of secondary coil. So I can go for NS should be less comparing with NP. Okay, more number of turns will be on the primary coil. So appadina current order what is going to be the relation of current? Very good Jehi, very good Srivarshini, very good Divya, Srimukhi, Angeline, Manju, very good. So that is what the thing. Okay. So next on the efficiency. The efficiency what we are, okay, I have given this much, you have given this much. So what will be that ratio? So output power divided by input power into 100. Output power we know that power is equal to VI da. அப்படினா output power சொல்லும்போது VS IS, which means நம்ம secondary இருக்கிற power divided by நம்ம input, which means நம்ம primary circuit இருக்கிற power, which means VP IP. If it is an ideal transformer, this value should be coming as 1, or else I can say that output power will be equal to input power. Understood everybody? Please let me know, guys. Please let me know. Everybody please let me know. Everybody. Yes. So now we are going for the thank you so much. Okay, so I know that it is very difficult to stay with the concept only. In between problem solving it will be very in the listening and we can just do something. I'm just trying to finish one more chapter. We can just go for the part 2 as we will be doing it on day after tomorrow or something, we can go for the part 2. So let me just finish one more chapter. I can understand you people are also feeling really tired. It is almost for 3.5 hours you are listening the physics concept. It is hectic. I can understand, but what I can do right now? Okay, I can't do anything right now. So please let me just finish one more chapter. Without a part 2, we can just do it as a some other day. Okay, day after tomorrow, I think we can just do it. Okay, va? Ready, Ada? All good, all good. Let us go for electromagnetic waves. Adu few hours we can, few minutes we can. Okay, few minutes we can just finish them. Okay. So right now displacement current da. Okay. So right now, no, you people are not giving the energy. Okay, everybody is leaving, so I don't like it. Okay, so that is what the reason. So I was also, I'm losing my energy. But fine, we will just continue day after tomorrow. So you also won't feel that much hectic. Okay, no issues, I can understand. Okay, so day after tomorrow, we will continue with the rest of the part. The whole 6 chapters, I think so, right? Ray optics, wave optics, dual atom nuclei, and one more is the what was the other chapter? Semiconductor. So in the 6 chapters, we can finish it on. Thank you so much for the 5 years. Okay. Oh my god. This is what actually making me, even if I'm feeling like okay, exhausted, fine, but my students are there. So andaru feel correct. So yeah, I don't know how to express my feelings. Thank you so much. So right now let us go for the displacement current. Okay. So displacement current comes into play in the region where the electric field and the electric flux are changing with the time. Okay, varying electric field. Okay, varying electric field will be giving the displacement current, and the expression was the epsilon naught into the rate of change of flux, electric flux. This is the actual displacement current. In the mathematical expression is very important. And also we have studied, okay, in the last chapter we have studied about the Ampere's Maxwell loop. Okay, what we have studied? We have studied about the what is the line integral B dot dl will be equal to mu 0 the current enclosed. Correct? That is what we are saying, conduction current. So Ampere's law actually he could only consider the conduction current, but actually it is not just, okay, if you are just finding the flux okay, if you are just finding the closed integral, line integral B dot dl the contribution is not just due to the conduction current, it is also due to the displacement current. That is what here it is coming, modified Ampere Maxwell law. Okay, modified Ampere Maxwell law. So closed integral, line integral B dot dl, which is equal to mu 0 into whatever we have studied in the last chapter, I enclosed, which means our conduction current, plus ID, which means our displacement current. Now, capacitor space so the field is varying with respect to time. So due to that there will be a flux change, and due to that there will be a current. Okay, there will be an induced current. So that is what the expression coming over here. So in the displacement current, we are actually giving the expression epsilon naught d phi by dt. So this is what the important thing which is coming in the beginning of this chapter. Next on the source and nature of the electromagnetic waves. The source definitely we know that accelerating particles and oscillating charges can produce the electromagnetic waves, and it will be transverse in nature. We can say if our electric field is along x direction and our magnetic field is along y direction, can you please let me know the direction of propagation? Can you please let me know? So, this mutually perpendicular, which means E, B, V. In the 3 things will be always mutually perpendicular. Now, I am saying electric field is along x direction and magnetic field is along y direction. Appadina, direction of propagation, very good Sri Varshini. It will be again mutually perpendicular, which is nothing but z axis. Very good, Elma. So this is what actually saying our direction of direction of propagation, where it is moving. Actually, so electric field okay, nama magnetic field so that will be again mutually perpendicular. Okay, again perpendicular. So right now this is what our the direction of propagation. The direction of propagation will be always perpendicular to the E cross B result. Understood? Can you give me a green heart if you understood this part? Okay, so now we are going for the another set, which is nothing but, let us say when the wave is actually moving in the positive x direction. Okay, wave is actually moving in the positive x direction. So right now we are assuming electric field oscillating in the y axis. Okay, nama particle is actually oscillating in the y axis. Nama electric field will be E naught sine kx minus omega t, and also nama magnetic field it will be B naught sine kx minus omega t. Just look at the direction. It is propagating along x direction. Okay, it is propagating along x direction. Appadina, if it is propagating along x direction, definitely electric field and the magnetic field should be mutually perpendicular. It can be y or z. Okay, it can be y or z. And how we will be, how we will get to know this electric field is along y direction and this magnetic field is along z direction? Very simple. We will be again use this expression E cross B should be in the direction of I cap. They have mentioned positive x direction, which means direction of propagation is I cap. So what should be the direction of E? What should be the direction of B to get V in the direction of I? Are you guys getting what I'm saying or feeling exhausted? Could you please let me know? So if you on actually they have given, okay, in the wave is propagating in the positive x direction. So I know that E cross B order resultant direction actually nama velocity illana in the wave will move, which is given in the question I. Now the thing is like there is no other things which is given. Only this is the given data. But you have to tell me what is going to be the direction of E, what is going to be the direction of B. So definitely E should be in the y axis. Yena J cap cross K cap can only give I cap. So I will understand electric field is along y axis and the magnetic field is along the z axis. This is what the thing which we will be. And also what is E naught and B naught? That is the maximum peak value. K is our propagation constant, which will be nothing but 2 pi by lambda. Omega 1 it is nothing but 2 pi into f. Understood? Now can you give me a white heart quickly? Everybody. So now we have magnetic field if electric field is given and vice versa. Ma'am, can you explain? That is what Elma we have done. Okay, any of the direction should be given. Okay, so if in the case C or a direction that given, if it is B, then just understand what must be. Okay, the cross product it should be this one. Okay, and the mother you have to work it out. So now tell me, if speed of electromagnetic waves. Okay, so we know that C value is 3 into 10 to the power 8, which will be equal to 1 by root of mu naught epsilon naught. When it comes to a medium, what will happen? It will become 1 by root of mu epsilon. What is mu? The permeability in the medium, and what is epsilon? It is nothing but the permittivity in the medium. Now you can replace this. Okay, I know that what is the permeability in the medium. We know the relative permeability which is coming as the mediathil permeability divided by mu naught. Am I right or wrong? So what will be this mu value, or let's say the the permeability in the medium? It will be coming as mu naught mu r. Like this way, I'm going for the epsilon as well. What is epsilon? The permittivity in the medium, which will be coming as permittivity in air into relative permeability. So now I'm just going to substitute that value. What I will be getting? Root of epsilon naught epsilon r into mu naught mu r. So now I'm just rearranging. What I will be getting? Root of epsilon r mu r into 1 by root of epsilon naught mu naught. And idoda value what is that? Number C. So I'll be replacing this equation as C divided by root of mu r into epsilon r. Understood, guys? Are you guys getting what I'm saying? Please let me know. And also, what is root of permeability? Relative permeability into relative permittivity. It is nothing but number refractive index. So I'll be replacing it as C by mu, or let's say C by N. Okay, mu already used, so I'm just replacing it with N. N refractive index of the medium. Next one is nothing but amplitude order relation. E naught by B naught, again you will be get it as C. So you can also even going for RMS also, again root 2 will be coming, that will also get cancelled. You will be eventually getting C, and also E by B will also give you the value C. Understood everybody? Everybody please let me know. So these important relations, important relation that everyone should study, and guys don't forget to like this session. Everyone should like the session. Everyone should like the session. Yes. Okay. The electromagnetic waves, even if you are by hearting few things, will also give you that 4 mark. Okay. One question will definitely come from electromagnetic waves, so that you can just study. So 4 marks from the easier you are going to get. Okay. So now another thing. Okay, another thing which is coming is nothing but energy density. The energy density will be coming as half into epsilon naught into E RMS square, and we can also say E RMS na E naught divided by root 2 da na. So while we are substituting, we will be getting E naught square divided by 2 it will come. So 1 by 2 into 1 by 2, 1 by 4 it will come. So we will be getting 1 by 4 into epsilon naught E naught square. Next on the magnetic energy density, the same, like the same way we will be just substitute RMS value and the maximum value. Next on the total average density, so total average density is actually on the density value, okay, whatever you are getting, okay, in the two values equal. So you can just say that 2 times this value, okay, the average value same, and you can just say this is going to be 2 times this expression, okay, wow? So next one is nothing but the intensity term, so that is nothing but the average energy density value into C. So whatever you got it in the previous case in terms of electric field you will get, in terms of magnetic field you will be getting. Depending upon the question, you can choose the equation and you can multiply it with C, that will be giving you the intensity value. So next one the wave properties. So actually you guys have to study this. Okay, if you're feeling like this is a lot messed up, okay, I don't want to read everything. Radio wave, this is the range for lambda, this is the range for frequency, and this is how it is produced, and the madri I'm not telling you. Okay, you can just study from here. Illana nama NCERT la last page, nama electromagnetic waves chapter oda last page irukku, and the last page neenga vandu paatha podum, you will be get to know, okay, you will be get to know about the whole details, everything they have given, the range, ellame it is given. So guys, again one more time I'm going to introduce this thing. So please have a look. So first neenga vandu paathena nama free Re-NEET crash course next 20 days la ipo vandu if you are getting more resources na, it will be very much helpful da. So adukkaga nama free Re-NEET crash course irukku. So nama first link da, so adula vandu click pannitena you will be getting an option buy now. So you see here 4999 oda course vandu ungalku vandu zero price la kedaikka porum. So you can just go for buy now, so then you can access this one. So idhula vandu paathena you can see the physics, chemistry, biology classes, and also you can see 24/7 doubt solving. Okay, it is not easy, that 24/7 doubt solving, and it is also based on the, okay, that is what the highlight, it is actually based on the nama NCERT, based on the whatever you are asking, okay, in the chapter la irundha whatever you are asking, it is all coming based on nama NCERT da. So idu vandu 24/7 unlimited you can ask, okay, unlimited actually vandu you can ask your doubts. So that was the major advantage. So guys, I hope everybody has joined, and how many of you have joined, can you please let me know? Library koncham issues irukkuda, it is actually the team is actually working on it. So once it is ready, we will let you know. Okay, got it? So how many of you have already enrolled in this? Please let me know. And also you can see here nama second link paathena, okay, second link paathena, this is actually directly going to the Amazon app. Okay, so 549 rupees actually you are going to get almost the most probable expected questions, 2500 questions order. Join, very good. Okay, 2500 questions oda oru book da you are going to get it. Last few days la question practice is very important. I hope enna vida you know better than anybody else, right? Okay, question practice evlo mukkiyam, adu vandu neenga vandu you already got the chance to write the exam. So அந்த ஒரு டைம்ல you already got to know, okay, நான் வந்து இவ்ளோ question practice பண்ணிட்டேனா definitely எனக்கு வந்து அதுல benefit இருந்திருக்கலாம். So அந்த மாதிரி you will definitely feel So my students, I wanted to tell you, if possible, please everyone should buy this. Okay, 549 rupees da. So actually when you people are spending a lot of money for unwanted things, so please just spend for some wanted thing. Okay, so yes, Nambike, I have taken it, ma'am. It is so nice. Okay. Sushmita, right? My brain is working like a hell. In that book, so difficult question is there, ma'am. In that book, you're asking, or you feel like it is very difficult. Can you please let me know? Okay, so actually வந்து நம்ம கிளாஸ்ல இந்த கிளாஸ்ல ரிவைஸ் பண்ண ஃபார்முலாஸ் வந்து you can just stick with this only, but question practice is very important. Don't think like, ma'am, நான் வந்து ஃபார்முலா எல்லாமே ரிவைஸ் பண்ணிருக்கேன், so definitely எனக்கு வந்து 180 out of 180 கிடைக்கணும்ல அந்த மாதிரி. Don't think that is what the problem. Okay, so yes, but I have taken ordered, ma'am, but not getting it till now. How many days da? How many days, please let me know. So actually you can track it, no, when you have ordered. And also idhula vandu 20 OMR sheet irukku, 20 OMR sheet. So in the next 20 days la you can go for 20 mock test with OMR proper. You can just check it. Okay, I thought I forgot all formulas for class 12, but now I feel very confident that I know at least 90% of the formula. Very good, Joshua. And I have seen multiple times you were giving the right answers, and that is what the important thing that you should understand. Okay, it is not about I have learned, I have. Okay, why it is coming like this? Yeah, so actually வந்து சொல்லும்போது it is not about, okay, it is not about yeah ma'am I have studied, okay, and the மாதிரி இல்ல, you could remember and you are just giving the answer, so that is the good thing. Okay, very good, Joshua, very good. So guys, so this is what I want to tell you, and marakama like pandra. Why you are not liking the session? I don't understand. Okay, did I do anything? You're watching, you're getting the concepts and everything, you're feeling very much confident. Ana vandu like adu mattum thara mudiyadu ma'am, annala mudiyadu. Formula sheet I have told you na, Divya or Diya. Okay, you can just check in the live session. Illana nama videos la kuda I have done formula revision. You can just check it, and adula in the description box la paathena you will be getting the link. Okay, got it? Yes. So guys, how about number first volume complete arke class 12 oda first volume complete arke? What is your confidence level, or how you will be rate the class? Okay, if you are feeling like very much confident, give me green hearts, more green hearts. When green is coming, no, as I mentioned, a green forest madri da theriyudhu. So yes. So guys, so everyone should okay, so everyone should read whatever you have noted down, and in the PDF one in the session kapram you will be get it. So guys, don't forget to study, revise pannalena, there is no point in learning listening. Okay, yes, class over ada, class over tha. We will just continue with this in the next I think on Thursday we will continue. Okay, yes, I could see the green part. Okay, so guys, just study everything in the PDF and in the class முடிஞ்சதுக்கு அப்புறம் you are going to get. Okay, மறக்காம download பண்ணிக்கோ, and also study as soon as possible. ஏன்னா வந்து hardly 20 days தான் இருக்கு. இன்னைக்கு வந்து June 1st. Okay, 21st க்கு தான் exam. So last few days la evlo conscious ah irukanum, evlo study பண்ணனும், அது வந்து you know better than anybody else, right? 100 out of 100, ma'am. I love the session. Thank you, da. Thank you so much. Thank you. Yes. So guys, don't forget to download the notes and also read whatever you have studied today. Please read as well, because now otherwise you cannot get the good score. Okay, revise pannalena, there is no point. Purinjida? Everybody got it? Yes. So thank you so much, da. Thank you so much. I am so happy that many students from the beginning, I can see Srivarshini was there from the beginning, Manju, Jia was there from the beginning, Yelma, I think you came in between, right? Yes. So on the mother, many students, Joshua was there, and Samiksha was there, Sushmita was there, yes, Angeline was there, yes, Srimukhi. Yeah, so idellame vandu it is, I'm feeling really honored, and I'm feeling so proud that my students could. It is not easy to listen the concept for long time. 4 hours இருக்கு. இப்போ வந்து 4 hours we would just keep on just listening the concept. அது வந்து அவ்வளவு ஈஸி இல்ல. Okay, for me it is easy. Anyway, I'm talking something. Okay, so right now அது வந்து next class இன்னும் முடியலடா, part 2 இருக்குல்ல, அந்த part 2 முடிச்சதுக்கு அப்புறம் I will tell Gia. Okay, who was asked? Not Gia, right? Grishma, I think she went. Yes, Shanmari, good night. Love you, Dora ma'am. Okay, love you too, dear. Okay, so good night, but before good night, you should read everything. Okay, make proper notes. Whatever you have missed in your old note, adu vandu add panniko and just revise it properly. Illena, there is no point of attending this 4 hours. That's a kind request. Okay, so marakama next session la vandu join pannikoda. Idoda part 2 da we will be continue with the rest of the chapter. 6 more chapters irukku. Idellame vandu we will be finishing in a single day. Okay, ready? Good night, good night. Thank you so much. Bye. Waiting for part 2. Okay, Gia, I'm also waiting. I'm so excited. How many of you will come? Let me check. Adala vandu punishment kuda irukku. Okay. Yes, Diya or Divya da, Jason, Divya or Diya. Somehow I'm just, what to say, writing all your names and everything. Again, in between, I will again forget. So guys, thank you so much, da. And Marakama like paniko, those who forgot. Yes, Divya, I won't forget. I'm a chitti robo madri. Okay. So see you da. Bye. And guys, don't forget to like the session. Thank you.